Welcome to the live stream of the Terran 1 rocket. We are of course hosting as ASTRA. We are a student group that operates out of the Bremen area. A lot of university students in the Bremen area, and we are interested, of course, in launches like the Terran 1 because we're all engineers and we're very interested in what is new about the Terran 1. If you may have picked up a couple of hints from the launch animation that we had at the start there, this is a bit of a unique vehicle because of some unique characteristics, specifically in how the vehicle is actually built. So as you know, 3D printing technology has been something that's kind of taken the engineering world by storm over the past couple of years, I would say. But it hasn't really been attempted to actually try and 3D print an entire rocket yet. And that's exactly what's changing here. Relativity is actually trying to 3D print an entire rocket. And that's what the Terran 1 is. It's the first prototype vehicle that they've been working on for the past couple of years. And their idea is that they want to basically 3D print an entire rocket and have it be like the tanks, the engines, all the components, the nose cone, the aeroshell, everything, all 3D printed. So from an engineer's perspective, this is very interesting because it's a whole new look at what building a rocket can be. And yeah, we want to see what's going on here and maybe get some inspiration. At ASTRA, we're trying to build a rocket that goes to space, and we're using 3D printing as well for parts of the rocket. Not for the whole thing, like they are with Relativity, of course. But the more we can incorporate this technology into our purposes, I think the more we can potentially gain the advantages that Relativity has. So yeah, let's see how this goes and see if they'll be successful in getting this first attempt going. A couple things to keep in note though as we go here. I don't have a launch clock. There's a reason for that. This launch could kind of happen at any time in the next couple of hours here. They have a launch window that starts at 6 p.m. UTC. So basically they have 3 hours from then for which they could actually launch the rocket. I highly doubt they will launch at 6 p.m. They've already delayed like their T0 announcement. So basically, I'm pretty sure they're not going to launch at the start of the window. So kind of expect delays here. This is the first launch of this vehicle, so there's going to be some hiccups along the way. And yeah, let's give them some support. And remember, because it's the first launch, maybe reduce your expectations a little bit. This is a first for rocketry history in general. We've never had a rocket that's completely 3D printed. We've never had something that's used this type of technology to this extent. So it'll definitely be interesting to see how it performs in the end. A lot of this stuff is very well tested though, so it's not like it's completely a one-off test. They've done lots of engine testing and different types of tests over the last couple of years. So, but it's always interesting to see what happens when it all comes together though. I can say that from experience. So yeah, we will of course be switching to the Relativity live stream. They're doing a live stream of their rocket launch. When they get closer to launch, we'll switch over to that. But in the meantime, we should take a little bit of time to get ourselves familiar with the vehicle and what makes it so special. So for the Terran 1, it's a kind of in the medium class of lift vehicle. So it's about 35 meters tall, has a diameter of 2.3 meters. It's able to lift about 1,250 kilograms into low Earth orbit. That mid-range launch vehicle is basically going from about 1 ton to about 10 tons or so. So it's not a small sat launcher like a lot of the vehicles that are coming online these days. It's actually addressing that middle part of the market, which actually speaks volumes to how successful they are with this 3D printing, because 3D printing a rocket that's this big is truly a monumental challenge. Like, think about that. They've 3D printed a structure that's 35 meters tall. That's like the height of like a 10-story building. So you might wonder, like, do they need like a 10-story 3D printer in order to do that? Well, that's not exactly the case. They have a specific strategy for how they're going about actually doing this. And we'll get into that a little bit here. So here you can see like their factory, and each of those 5 steel doors there is housing one 3D printer. So what they can do is they actually print segments of the rocket. So one of those printers can print like 4 or 5 meters, and they basically just stitch the segments together, like kind of like Legos almost on top of each other, because they have like housings with bolts and bulkheads and stuff. So they can put all of these segments together, and then that makes the entire vehicle. So essentially, the vehicle is entirely 3D printed. And even though one rocket doesn't fit on their print bed, so to say, they can put a bunch of parts together that are 3D printed and assemble an entire vehicle. And these 3D printers are really like the top of the technology in terms of what they're able to achieve, because of course they're 3D printing aluminum here. The whole vehicle is made out of aluminum. And they're able to print these giant structures because of the unique technology that they're employing with their software on these 3D printers, which allow them to address some of the issues with printing something this big out of metal. There's lots of things like shrinkage and the way metal warps as it gets heated that cause issues with printing something this big. But they're able to, of course, address this with the printers they have. So it'll be interesting to see this all come together and to see if it'll actually work in the end. Here's a quick time lapse of what it looks like when it prints. So basically it just has this like 3D print robotic arm, and the table below is spinning, and that's what allows them to basically address the entire workspace and create the 3D print. Yeah, it's not like a typical in-house 3D printer that you might buy off the market where it's like a table and it has like different axes of rotation. This one is specifically designed for printing rockets, which are of course cylindrical things, so they can use the spinning table to really do a good job of that. What I would be interested to see in the future is them try to approach different geometries for the tank and for the rocket structure, because once you have a 3D printer, you can kind of do anything. So maybe they might find some better ways to actually build rockets that are not just a cylinder and the tubular design. But anyways, let's switch over to the Relativity live stream here. They've just started up. It looks like we have about 56 minutes on the clock, so we'll see what's going on over there.
Liftoff is currently scheduled approximately 56 minutes from now. This estimation may change as we work through our countdown. We'll keep you updated along the way. Today's launch window lasts for about 3 hours, giving us time to troubleshoot any issues. If any unforeseen issues arise during the countdown, we can pause the launch sequence if necessary. And with that, Arwa, what's the mission status update?
Well, as you said, we're at T-minus 55 minutes and counting. We just received confirmation that propellant load is wrapping up for both stages. The weather is trending in our favor. However, we're keeping an eye out for medium winds that are gusting at about 22 miles an hour. And there are a few scattered clouds, but conditions are currently within limits. So the range is green, the vehicle is healthy, and we're progressing well towards our scheduled launch time.
This is so exciting. We're getting closer and closer.
This is definitely really good to hear that the weather is looking good and that propellant loading is going well.
Screen, you can find our countdown clock to help follow along in our pre-launch operations.
And now, ahead of our terminal countdown, here are some other quick facts to bring you up to speed on Terran 1. This launch vehicle is a 2-stage expendable rocket. It stands at 110 feet tall and is 7.5 feet in diameter. As far as we know, this is the largest metal 3D printed object to exist, much less attempt orbital flight. It is 85% 3D printed by mass, and there are 9 Aeon 1 engines on the first stage and a single Aeon vacuum engine on the second stage. All Aeon engines are, of course, 3D printed. Terran 1 and Terran R are both Methalox rockets. This means that they use a combination of liquid natural gas, predominantly composed of liquid methane, and liquid oxygen, hence Methalox. This propellant combination is becoming the choice for next-generation reusable vehicles, including our next rocket, Terran R.
Interestingly enough, that flare tower that's there, do you see the flame that's coming out of the tower on the side there? That's actually because of the methane. So basically they're filling this whole rocket up with methane. And as they do this, there's going to be some methane that's like leaking, or they have to kind of let off into the environment because the tank is having to keep it cold. And so you don't want to just let that into the air, and basically they'll flare it. It's kind of a safety / environmental thing to do.
While costing less to build and fly. And if that wasn't enough, we have the long-term vision for expanding the possibilities for the human experience by creating humanity's industrial base on Mars.
And building large-scale metal 3D printers could make Relativity's mission possible, including early Martian settlements. We see 3D printing as an automation tool. It allows us to remove fixed tooling and really embrace software-driven manufacturing. I mean, our first 3D printers were developed about 7 years ago, and since then, we've improved on speed, scale, and complexity across 4 generations of printers. We intentionally started with orbital rockets because we saw an incredible market opportunity in space, and we believe they're among the most complex proofs of concept to develop this advanced manufacturing technology. There's also a natural incentive cycle between 3D printing and rockets. The lighter weight a 3D printed product is, the faster it is to build, and thus the cheaper it is. The desire to make a rocket lightweight is really to ultimately increase our payload capacity. This also means we can optimize for cost, build and iteration time, total part count, and reduce fixed tooling. Our Stargate printers were used to manufacture our Terran 1 vehicle, and we're currently expanding into a 1 million square foot facility known as the Wormhole to allow us to continue the manufacturing of Terran R. This isn't only exciting for our internal teams, but it's also exciting for our customers.
Terran 1 and Terran R have already been met with significant market interest. To date, Relativity has publicly announced nearly a dozen signed customers for commercial and U.S. government payloads. Some customers include OneWeb, Iridium, NASA, and the Defense Innovation Unit. Currently, Relativity's customer contracts amount to more than $1.65 billion. Relativity is a private venture-backed company. To date, we have raised over $1.3 billion in capital with our most recent $650 million Series E round.
That's right.
That's quite astonishing that they've raised so much money before their first launch. That's very unique for a rocket company, I would say.
Today is International Women's Day, and to give a shout out to our hundreds of incredible female colleagues who are contributing to Relativity's mission. I am so proud to work alongside you all.
So I just wanted to talk a bit more about the engines that they were just mentioning, the Aeon engines. Basically, these are going to be what are powering the Terran 1, and they are very interesting. They did mention in the live stream there that they are running on cryogenic methane and oxygen. Of course, that's a very new kind of fuel type for rockets these days. It was kind of kicked off by, of course, the SpaceX Starship vehicle using methane and oxygen, and I think everyone kind of just decided all of a sudden that that was the thing to do. But it actually has a lot of benefits because it does get better specific impulse than the standard RP1 and oxygen would. Of course, it is a bit more difficult to handle methane, so filling tends to be a little bit more challenging. But, you know, clearly they've managed to deal with that problem. The other interesting thing about this is that these methane engines are actually running what's called the expander cycle engine. So basically, the heat from the engine itself is being captured by the methane as it flows through the nozzle, and then that is being used to spin a turbine which runs the pumps. So it's kind of like a regenerative process where the heat you get from the combustion is being used to actually keep the combustion going, with the pumps pumping the fuel in and the oxidizer. With this type of system, you typically can get up to about 100 kilonewtons of thrust, and that's exactly what these engines are able to produce right now, 100 kilonewtons. So they are pushing the technology of using expander cycle engines as well. So it'll be interesting to see a vehicle that's powered entirely by expander cycle engines. That's also something that I think is a first as well. But overall, it tends to be a simpler cycle where you don't have to use pre-combustion chambers and things like this. So it can actually have a lot of benefits. And they've done a bit of hot fire testing with this already. And by a bit, I mean quite a lot. They have like 500 tests already. And the reason why they can test so quickly and iteratively is because, of course, these rockets are 3D printed. So they can basically, have a test, realize something went a bit wrong, and then quickly go back and just print another one. Having the printer in-house like that, where you just can print something and be ready to go, is such an advantage when it comes to design iteration. So yeah.
During acceptance testing, the vehicle withstood loads even beyond what we anticipate it will encounter during flight. So passing this milestone would effectively demonstrate that 3D printed rockets are structurally viable. If we make it even further to stage separation, we will have achieved a full first stage flight, and that'll be another big accomplishment from the team. From there, we'll attempt to light the second stage and get Terran 1 to orbit.
So at this point, I'll be honest, it'll take some restraint to keep.
Those clouds that are coming off the rocket right now are because they are, of course, still filling up the vehicle, and the liquid oxygen that's in the tanks needs to be kept at cryogenic temperatures. And when that's the case, there's, of course, the heat from the environment that's coming and wanting to vaporize the liquid oxygen, and that causes the tank pressure to rise. So in order to keep the tank pressure from getting too high, you have to let some of that liquid oxygen go, and that's what you see here, those vapor clouds.
With the FAA and Space Launch Delta 45, these protocols are of course standard for all launches and ensure that no one would be in harm's way if there were to be an anomaly.
And as a reminder, there is no customer payload on this flight. Instead, to celebrate how far we've come, we've mounted our first ever metal 3D print from the first generation Stargate printer inside of Terran 1's nose cone.
That's actually really cool.
And while we're on the topic of setting
That's
expectations, we will also note that we are unsure how much of the second stage flight we will be able to share with you live. While we do have cameras on board, we will be prioritizing vehicle telemetry sensor data for this launch in order to maximize our learnings. And as a result, the video connection could be spotty. In the event that we do lose our video, we will do our best to keep you up to date as we receive telemetry. Now let's talk about the countdown overview.
Well, the window for today's launch attempt opens at 1300 Eastern Time and lasts for 3 hours. The pad was cleared of all personnel at T-minus.
At least they're going to attempt to show the video from the second stage. I know that most rocket companies don't do this, so it's definitely very cool to see the new ones trying to do this, because it's very nice for us public viewers to see more of the flight.
We'll poll the launch teams to ensure that all subsystems, weather, and the range are go for terminal count. Terminal count will then be at T-minus 70 seconds, and it's when the vehicle's internal flight computer takes control of the countdown. Now, while we wait for T0, let's talk about the process that got us here. So again, Terran 1 is 85% 3D printed by mass. The items that are not 3D printed include rubber seals, computer chips, valves, and other similar items. Relativity sees 3D printing as an automation technology, and we believe that long-term 3D printing will rapidly democratize space. We've already been able to unlock rapid part count reduction and rapid design iteration, and we're still in the early days of what's achievable. Now, we use 2 classes of printers here, powder bed fusion, or PBF, and vertical wire arc additive manufacturing, or WAM.
PBF is a process that uses a heat source, such as a laser, to sinter or fuse powder particles together in a layer-by-layer process.
This
what
is
you
for more
see
of
on
the
the table
small
in front
stuff.
of me are a few sample PBF printed parts. These are not flight parts, but just examples for us to see today what kind of parts we could print using this technology. For PBF, we use this technology to print our Aeon engines. These are the 9 Aeon 1 engines on the first stage and the single Aeon vacuum engine on the second stage. PBF has allowed us to increase our reliability through lowering our part count.
And on the other hand, our proprietary Stargate printers use WAM for printing the vehicle structure.
This is the one that they came up with
The material we use is a
themselves.
proprietary metal alloy developed in-house. It begins in a wire spool, and that wire is then fed into a Stargate printer. It's then heated and cooled rapidly to form small beads that in succession create the vehicle structure layer by layer. That includes the Stage 1 and Stage 2 tanks that hold the propellant, their internal ribs, the common domes, and the nose cone. This is essentially what makes up the bulk of the visible part of the vehicle on the pad, except now it's painted white instead of the native silver that you see here. Now, I do want to mention that our Terran 1 was vertically printed using our 3rd generation printer, but our 4th generation printer will move horizontally to increase print sizes for our next vehicle, Terran R. But of course, the star
That's
of
really
today's
interesting.
show is still Terran 1.
That's right. Let's do a deeper dive into Terran 1 and walk through the architecture shown on the screen.
So we already went over this a little bit. Maybe we should get into a little bit of what the Terran R is that they keep referring to. So of course, this vehicle that you see on the screen right now is the Terran 1, which is the one that's going to launch today. But they are not stopping there. They have some big plans for what's called the Terran R. Just to give you an idea of what this is going to look like in comparison. So the Terran 1, again, is on the left. The Terran R is on the right. So it's kind of like the almost like the Starship for relativity space, because their plan is to make this vehicle entirely reusable. You can see kind of in the middle there, they have some what look like grid fins on the first stage. And then on the second stage, kind of looks a little bit like a Starship vehicle where they have these like stubby little fins on the side. And essentially, in order to print this big of a structure, they need to kind of change the way that they're going to be using their 3D printer, the WAM one. Basically, instead of printing vertically like you saw in the previous time lapse, here's another example of that. This is actually the first test build that they did for the Terran R. You can see here that they're really stretching the ability of their print bed to handle this wide of a tank. So they kind of need to change their strategy with how they're actually going to 3D print this big of a structure. This is just the bottom base of the tank that they want to print. And I think they might have not been so happy with the results on that, and they obviously are looking to modify and upgrade the technology they're using to do that 3D print. But yeah, this is going to be what the Terran R is going to look like. It's also, I think, going to be running on methane and liquid oxygen. And of course, their goal is to make it entirely reusable. So not only will it be 3D printed, but it will also be completely able to be reused and hopefully achieve many, many flights. It'll be interesting to see if they'll be able to come up and solve the challenges that they need to, because obviously this is still an aluminum vehicle and that has some difficulty with re-entry heating. So I'll be curious if they're able to, what their solution is to kind of solve those problems. But definitely looking to see where this is going to go in the future.
All data from Terran 1 development will be fed into Terran R. But our Terran 1 rocket is only a part of the formula. We also have a historic launch location.
That's right. We are launching today from historic Launch Complex 16 at Cape Canaveral Space Force Station. Between 1959 and
That's down in Florida.
1988, this site supported a total of 141 launches. It was initially built for the Titan missile launches, and it was transferred to NASA for Gemini crew processing and static test firing of the Apollo service module's propulsion engine. The Air Force then used it from 1972 to 1988 for the Pershing missile launches. After that, the site sat abandoned, and Relativity then got the right of entry in 2019. In 2020, we initiated land clearing and construction. We built the whole site from scratch, and in less than 2 years, the team cleared, demoed, and built the pad to what you see here today.
There's a ton of work that goes
This
into
includes the
that.
pad deck, the transporter erector, all the commodities and utilities, the office space, and of course the integration hangar. We conducted multiple hot fire tests after that and are here today to launch. Good luck, have fun. This will be the site's first launch in over 35 years. Now let's take a minute to visit our facilities across the country.
So one thing also to think about is, how does the Terran R actually stack up against some of the other launch vehicles that are in the market right now? And of course, it's a medium lift launch vehicle, so comparing it against some other medium lift launch vehicles that are coming on the market today, I think that the Firefly Alpha is a good comparison. It's They have very similar specs in terms of the dimensions of the vehicle and what the vehicle can achieve. Both are able to get, just over a ton into low Earth orbit. They have similar thrust levels. They're both servicing mostly LEO and SSO. So what they differ on, basically, in the end, is essentially the cost. So here you see that the cost of the Terran 1 is only 12 million, whereas the Firefly Alpha is looking to be about 15 million. So it'll be interesting to see how Firefly Alpha has to deal with the competitiveness of Terran 1, supposing that it is successful in the end. Yes, the Terran 1 will be launching from Cape Canaveral. It's one of the older launch pads that they have on site. I think they said it was Slick 16. It was used a lot back in the 60s and the 70s, but has not really been used much recently. And of course, they got the lease for the land and are able to launch from that now. Yeah. So when you compare these two vehicles, you can see that maybe the Terran 1 is looking a little bit more positive. But I think what's deceptive here is that these are the Terran 1 costs now, right now, today. I think that they're going to be able to get these costs down if they're really able to lock down this 3D printing technique and turn it into kind of a factory process. I think that they have the potential to really, really compete hard in this market. And especially when the Terran R comes online, I have no doubt that they will be extremely competitive with the likes of even SpaceX competing in the heavy launch market. So I'm looking forward to that as well. Another thing to think about today would be the mission profile that we're expecting for the vehicle. Of course, this is just a test launch, to be clear. So there isn't actually a dedicated payload, like a customer that's riding on the top. Instead, it's just, they say it's their first 3D printed part that they ever made. It's like basically this metal ring. It weighs about 1 or 2 kilograms. So it's not a super ambitious payload, but of course, they're just trying to verify that the system's working and that they can achieve what they want to achieve. So we're going to have liftoff at T-0, which is going to be in about 35 minutes from now. And then after about 2.5 minutes, they're going to have what's called MECO, where the main engine is going to cut off. And then the first stage is going to separate, and the second stage is going to come out, and it's going to ignite. After that, we're probably not going to get super reliable video, but hopefully we get a couple snippets. That burn is going to go for about 5 minutes, and then essentially the payload will be inserted into orbit. Unfortunately, the Terran 1 rocket, the first stage, will not actually be landing itself. It's going to land in the ocean and unfortunately become scrap metal. Of course, this is not the future for Relativity. They want to move to full reusability with the Terran R, but Terran 1 is just a single launch vehicle. It is not reusable, so there will be no reuse attempt.
You see behind the rocket. The 4 large towers surrounding the pad make up our lightning protection system. They protect the vehicle from any direct lightning strikes. Inside of those, we have 4 small black posts around the pad.
Interestingly enough, lightning is actually a real threat to rockets.
They're used for acoustic mitigation for the rocket and do so by covering the pad with water to dampen the reflected acoustics. The small flame that you see there at the bottom right of your screen is the flare stack. It burns off flammable gases from propellant loading, venting operations, and priming of the engine igniters. It's a little harder to see, but the small slide-looking structure beneath the vehicle, there it is our water-cooled flame diverter. It's used to mitigate the heat from lighting the engines, and it directs the exhaust plumes away from the vehicle. You'll also be able to see what looks to be 3 different levels under the rocket. The largest and lowest level is the pad deck, and directly above it is the launch table. This is where the launch mount pins to the pad.
As far as we know today, the Terran 1 is not planned to be reused, so I wouldn't expect that to be something that pops up. The Terran R will be reused, and it will be reused upon like the first launches, like they're going to try to reuse it immediately. kind of like Starship is trying to be reused immediately. However, I wouldn't be surprised if they do a couple of like tests with the Terran 1, like on the down low, where they, attach some sensors to the first stage and like see what they get in terms of like heating, and if there's actual issues with the 3D printed aluminum. I think there will be. The heating that you get on going up to like just past the Kármán line and to the speeds that you need to get to for this first stage are quite high. Like the heating goes past 1,000 degrees Celsius. And of course, aluminum melts at 600 degrees Celsius. So that's an issue. You have to have a way to protect the aluminum from getting too hot. Of course, SpaceX does this by doing their reentry burns. But I'm sure they're going to need to collect some data, and I see no reason why they wouldn't try to do that with some of these stages. But no, they're not going to ever, as far as we know, they're not going to ever try to reuse the Terran 1. Yeah, so the trajectory for today is actually, they're just going straight into a simple low Earth orbit. So they're going to fly straight east. They try to get as much of the Earth's spin as they can. So basically, they're trying to make this as easy as they possibly can to get this payload into orbit. So it's just going into a 28.5 degree inclination orbit, which is what happens if you go directly east from Cape Canaveral. It's not like any kind of special orbit. There's no payload specific orbit they need to get into. They're just putting in their payload, which is a ring which weighs a couple kilograms. It's kind of like, sentimental value for them. Yeah, we do some live streams every once in a while. Whenever there's a cool launch that's coming up, we're a rocket group. We're, a bunch of rocket engineers that are trying to build rockets. So if there's like a cool launch that's going on, of course, why not stream it? Plus, it's fun to talk about and, learn what's going on. We use a little bit of 3D printing in our rockets, and, watching this group, Relativity, build their entire rocket out of 3D printed material is just crazy. So, yeah, I mean, if we can learn a little bit and see what they're doing and maybe steal some of their ideas, always great. We've been briefly considering 3D printing our rocket engines. It's quite expensive to do, which is why we've been hesitant about doing it. But yeah, if we can figure out a way to do it a bit cheaper and do it more like, and make something that maybe could be reusable even, it might be worth our effort. Yeah. Yeah, let's just say it's inspiring us. Inspiring ideas for how we can figure out how to build a rocket. Yeah, 3D printing is not patented in like the idea itself. It's just their specific system of 3D printing. Like this WAM 3D printer that you see that's on the screen right now. This is like definitely, I'm pretty sure it's patented. They're very secretive about how it works. There's basically a bunch of software in there that's proprietary to Relativity Aerospace. And yeah, I would be very interested to see if they start selling these 3D printers to the world, because there's so many cool things you can do with a 3D printer like that. Like, imagine all of the crazy structures you could build that are big, that are made out of metal, that would be so much easier with a 3D printer. It would just totally revolutionize how you could manufacture things. I'm very interested how much it costs as well. I'm sure it's probably in the millions. Maybe in the tens of millions. I think that's probably the most valuable thing that Relativity actually owns right now, is actually those 3D printers. Like, honestly, what you can do with that is just, it's completely limitless. And it's so required for building things in space, because if you go to the moon or you go to Mars or something, there's no tools. Like, there's no steel mill, there's no factory producing parts, there's no infrastructure to allow you to build like rockets. There's no rocket factory on the moon or something. And you got to build a base, you got to build materials, you got to build a society. If you could like ship one of those 3D printers on a rocket, and set it up and just feed it aluminum, and then it prints, an entire structure and an entire base, an entire a whole outpost. Like that's a huge step for like colonization throughout the solar system. Like this is one of the things that's required, I would say, and it's going to be something that's going to push us forward. Yeah, the little 3D printers use a different technology though. They use basically this technology where you have like a powder. So they put a powder of the metal onto the surface, and then they use lasers to like melt those little pieces onto like a structure. And it takes a really long time because these layers are really, really, really thin, and like to print a part that you could hold in your hand would take like a week in some cases. And they're very expensive. Like you said, they're hundreds of thousands of dollars. So not really usable for most people in the world. There are clear advantages to the technology that Relativity is offering here, where you can do things a lot faster and a lot bigger. So yeah, I'm excited to see when they sell the first one. That's when we're going to start seeing some development in other industries as well. Yeah, but probably outside the budget of student groups to attain, though, unfortunately. I would be curious if you could use this technology like in space itself. Like maybe you could have like 3D printers like on orbit that could like build space stations. Like this is the kind of stuff that this allows. Like if you just you ship up like rolls of aluminum, and you could literally 3D print like spaces. Because one of the problems with building things in space is that they have to fit inside the rockets that you send to space. So if you could actually just take 3D printer filament and send that to space and then build your structure as big as you want in space, like I said, the applications are endless. Yeah, a good example of the small metal printers. They're basically like those the balsa laser cutting kind of in terms of their capabilities, I guess. But of course, they're able to do it with metal and a lot more accurate, I would say, than balsa wood cutting. But yeah, it's definitely cool that they chose rockets as their first application, because it's definitely a serious challenge that can go wrong in a very big way. But if they get it right, it just proves the technology even more, because it's like you're putting these structures through crazy amounts of stress and wear and tear. So if the 3D printed aluminum can survive that, I mean, there you go. That's your proof of concept. Yeah.
As we approach T-minus 25 minutes, we're going to stand by for a situational briefing from the launch director, Clay Walker, in Mission Control. Let's listen in.
Hopefully they're still on target. Again, they have a 3-hour launch window, so that launch window starts in 6 minutes. Yeah, we're gonna see where they are in the timeline here. Don't be disappointed if they decide to scrub today. This is actually their first time they've put stuff on the pad and are like ready to launch. And if you know any of the other like small sat and medium sat launchers that have been developed recently, like it usually doesn't launch on the first try. So, well, I'm hoping that we actually get to see a rocket launch today. So keep your fingers crossed. What you're looking at right now is their mission control. It's not quite as advanced as the Situation Room in NASA, where they have like, 100 people all huddled around, but it works for them, I guess. Looking a bit windy out there on the pad, looking at those palm trees. But I guess wind is no problem for this rocket. Yeah, low expectations for the first launch is probably a good way to start, but keep in mind that a lot of these guys have learned from a lot of previous launches, so I wouldn't be surprised if it works on the first try. But it may take some delays, so keep that in mind. Oh. The mass of the 3D printers being big is not such a big problem for the future, though, because think about all of the big launch vehicles that are coming online, like Starship.
Us, we are just under T-minus 24 minutes, and we're currently waiting for an update from Mission Control.
Yeah, so like think about it, like those 3D printers that they have right now, they could totally fit inside of a Starship fairing. So just put one of those in space, and then boom, you've got a whole factory to assemble space structures. And if you want to really get crazy, you could even maybe, like if this technology keeps developing, you could maybe even start putting 3D printers like in space dedicated to building space stuff. Like not just like structures, it could be other things as well. Satellites, infrastructure. Yeah, this is the first step. Yeah, less. The key is that if you can figure out ways to get payloads inside of rocket fairings and make them so that they can become bigger in space. Because in space we need things to be big in order for them to be useful in a lot of cases. Like think about it for like telescopes, or for habitats, or any type of communication stuff where you need to have like big dishes and big hardware. One of the huge problems that you have with aerospace is just you can't fit that stuff into a fairing. Like look at all the trouble that James Webb went through just to have a mirror that was 6 meters in diameter, Imagine if you could 3D print a telescope. That would be crazy.
And I do have an update here from Mission Control. We did just get an updated T time from the range of 1400 Eastern. Again, that's 1400 Eastern. That'll be reflected shortly on the T clock. There you go. We are
so
now
it looks like
1 hour
we're pushed
away
back to
from
59 minutes. So, okay. Looks like we're going to be at least another hour. Yeah. It's always tough to get everything working on the first try, right? Because like when you're just starting up, you don't really know how things all play together fully. Like you can do a hot fire, you can do your structure testing, you can do your aerodynamic simulation, your wind tunnel, whatever. But when you put the whole system all together on the pad, there are things that come up that you just weren't expecting,
Is due to us wanting to get more time for propellant conditioning. We're going to stand by to hear more from Mission Control, but as of now, we are launching at 1400 Eastern.
I wonder what propellant conditioning means. Does that mean they just want to leave the propellant in the tank for longer? I'm not really sure. Yeah, they're already like they're not hard restrictions on max orbit heights like yet, but there are limitations. So like if you want to put a satellite into orbit, there's a process you have to go through where you get that okayed by the FAA or whatever the space entity is for your country. You can't just send something into any orbit, because obviously some orbits are more trafficked and they will limit the amount of satellites that go into those orbits. And they also have to take measures in order to reduce the chance that there'll be orbital collisions. So if you're going to be launching small sats or like CubeSats and stuff like that, usually you're not allowed to launch those into orbits that are higher than 500 kilometers, specifically because they need to deorbit on their own within 25 years. That's like a typical requirement that's put on all satellite operators. And for small sats, they basically assume that even if you have a means to deorbit that is like can take you out of a high orbit quickly, like, you know, a thruster or a sail or something, if those have a low technology readiness, they just assume that that won't work, and they say, okay, you have to have it automatically deorbiting.
No longer pause now. We are counting down. We are at now T minus 58 minutes and 18 seconds.
Good to see that the count is resumed. It's going to be a bit of a wait here, but we can chat a little bit and learn more about the vehicle as we go. There definitely is something like the FAA in Poland, I assure you. Yeah, there's all kinds of regulatory agencies all throughout Europe. There's one for every country. I know that in Poland, some of the rules are a little bit more lax, I guess. It can be a little bit easier to launch things as an amateur anyway and put them into high altitudes. It's actually still one of the options for getting our first launch done, because it's really hard to launch things from Germany, which is where we're from. So yeah, Poland can be an option there in some cases. But I assure you that if you want to go to orbit, you have to go through all the same stuff. Yeah. I'm not sure what the agency is though for Poland. Oh, did we see ice at the bottom of the rocket? I didn't see that. But yeah, that will happen, because basically the methane and the oxygen are being stored cryogenically. So if there's like a lot of moisture in the air, the water basically the water in the air will freeze onto the side of the vehicle. Usually that's not a problem though, because as soon as the rocket launches, the ice just breaks away. Not usually a danger to anyone or the vehicle. If there is so much ice building up that the vehicle becomes more massive, sometimes that can affect performance. But usually that ice comes off in the first 10 seconds. It can be a major issue if you have like boosters on the side, because that ice from higher up could fall and like hit the boosters below. This is kind of similar to what happened with the Discovery, the space shuttle Discovery. It had some insulation that came down and hit one of the boosters, and then that caused... sorry, this wasn't Discovery. This was Challenger. No, I'm getting this mixed up. Sorry, it was Discovery. Some of the insulation came off and hit the wing, and that's what caused the deorbit failure of that vehicle later on. So that could happen with ice, but in this case, the Terran 1 doesn't have any boosters. So again, I don't think that would be too much of an issue. But maybe, I don't know. Could be what they meant by propellant conditioning. Although I'm not sure how they would solve that, because they would need to like heat it up. Yeah, there are a couple of like amateur launch sites in Poland though, where you don't need so much. I don't think there are so many rules around it, but I'm not totally sure on that. Some other people in our group have better ideas of that than I do. We're hoping to be able to launch at Euroc this year, so that's our that's our primary motivation right now. That's a launch competition in Portugal. And there, basically, if you're a student group, you can come and you can compete to a couple of different categories of launching rockets. But it also offers a good opportunity for amateurs in the student community to be able to launch a rocket, because in a lot of the countries in Europe, you're actually kind of limited. And sometimes limited to just military options. Like, that's kind of what happens in Germany. So if you want to launch a rocket beyond about 1 kilometer, you basically have to cooperate with the military, which can be very difficult, I would say. Yeah, we can still see a bunch of clouds coming off the vehicle though, so I think they're keeping it filled. I think that's quite clear. So, I mean, I guess they're just gonna keep the fuel and the oxidizer in the tank for longer, and that's what they mean by propellant conditioning. The max is 150 meters in the Czech Republic. My goodness, you can barely launch a water rocket there. If you go too high, you'd be breaching. Are you allowed to fly drones in the Czech Republic? Because like 150 meters is quite a low ceiling. Yeah, you can definitely build a water rocket that goes above 150 meters. That's for sure. I mean, if you launched it above 150 meters, like, would they know? I feel like that's tough to police. They definitely got to do something about these low altitude ceilings in Europe. It really stifles the amateur community, I think. They could do with some higher altitude launch sites scattered around the continent. Yeah, that's another problem with the European community is that oftentimes like different types of solid propellants are like not allowed. This is an issue that we have in Germany as well. Basically, like even black powder and rocket candy and things like this are like restricted. So like you can't buy potassium nitrate in Germany. Whereas in like America, you could literally just go into the hardware store and get some. So this is one reason why our vehicle is actually a hybrid rocket, the one that we're building, which we want to get to space. It's because we actually physically would not be able to acquire the materials to build a solid one. At least not easily. We'd have to get like special permissions, and we'd have to have people in the group who are like experts in handling explosives. Plus we'd have to have like special vehicles to transport all of our materials. So if we wanted to, you know, move our rocket somewhere to a launch site, like you can't just put that into a truck and drive, you know, like you have to have a special truck that's certified to be able to carry these types of materials. It's really kind of a mess. Yeah, European airspace is definitely cluttered with commercial flights, that's true. But I mean, most commercial flights are operating much higher than amateur rocketeers want to fly to. So like 150 meters is a crazy ceiling to have, unless you're like literally right beside the airport. Yeah, a more logical ceiling would be like 3 kilometers, you know. And it would be nice to have like a couple of launch sites throughout Europe that, you know, can host those types of launches, because that's like a common altitude target that I think a lot of mid-level amateur rocketeers are trying to get to.
For
Here we
those
go.
just joining us, we are at T minus 49 minutes. As a reminder, we set back the T clock to allow us more time for propellant conditioning. In the meantime, why don't we talk about stage 2 MDC?
Great idea. One of the approaches we take here at Relativity is to be focused on having a lot of hardware that we can test in order to reduce our risk getting into flight. One attempt that we tried to do that was paved out through successful testing was stage 2 hot fire testing. This is where we took stage 2 to NASA Stennis and we integrated the Aeon vacuum engine with a stub nozzle. For this test, we filled the tanks with our cryogenic propellant, and this is also where we were able to fire the engine and see interactions between the engine as well as the stage. What's really important about this type of testing is that it allows us to reduce risk. It allows us to test our propellant estimation algorithms. It also allows us to test how we pressurize our tanks. We got so much learnings from these tests, and why don't we take a look at that journey to stage 2 hot fire testing.
So the stage 2 is the upper stage of the vehicle, which is, I mean, obviously it's the part of the rocket that's on the top, right? But the problem with it is that when you test it on the ground, you kind of have to be careful because you want to optimize for expanding into the environment. But obviously the environment that you want to design the rocket for is space. So when you do this, it's called under expanding the exhaust. And so there's only so much testing you can do of that on the ground. Of course, you don't really know how it will perform until you put it in space. But here you see some of their testing of that engine. Potassium permanganate instead of potassium nitrate. That's interesting. I've never tried that before. Is it easier to acquire? Is that why you chose to go with that, to go that direction? Because it's actually also quite easy to make potassium nitrate if you know what you're doing. So if you really wanted to, you could probably do that. It's probably also cheaper. But yeah, we just decided that, you know what, we don't want to kind of go through all the hassle of trying to, you know, legitimately make a solid rocket. Although solid rockets can be a bit easier in terms of their performance and, you know, handling things from a student rocketry perspective. But better to just instead skip the bureaucratic problems and just go towards the engineering problems, because at least those have technical solutions, whereas bureaucratic problems sometimes have no solutions. We're not bureaucrats in the group, right? I see. To be honest, I don't really have enough experience with the solids to really get into a debate about which ones are better or worse in terms of cost and things like this. But yeah, there's obviously lots of options. I mean, if you wanna have oxidizers, there's definitely tons of options to think of from a chemical perspective. It's just a matter of what is possible for you and your area and what you have access to. Yeah, buying stuff on the internet. I don't know if that's sometimes, like, okay, sometimes you can buy it on the internet, but the question is, can you legally use it? If you're just like kind of like a one-man show and you're just using it yourself, and you know, you're not really involving a lot of other entities, it's probably fine. But as a student group, you know, you have to be a little more legitimate about how you operate. So like if you are using oxidizers, you have to be like following the rules of the area where you live. Otherwise, you're not going to get to launch. They're not just going to let you launch your random homemade solution, you know. That's true. It is incredibly difficult to simulate hybrid rockets, which is definitely one of the problems that we're dealing with right now.
Do we need to wait? Can we get a brief update on the mission going on today?
Yes, so we are a little bit less than about 50 minutes until launch. We are still we took it back to be able to condition our propellant. So we're
I think
still
she said
doing that
50
at the
minutes.
moment.
She meant 50
But
minutes,
the range
50.
is green and the weather is looking great.
We are still moving forward, team. As we continue to wait, we just saw a video about stage 2 mission duty cycle testing. We reached that full mission duty cycle duration for stage 2. Similar to stage 2, for stage 1, we also completed stage hot fire testing. However, that was here at Launch Complex 16 instead of at NASA Stennis. We actually utilized our launch pad and adapted it to also have the capability to do stage 1 hot fire testing. Let's take a look at this video.
Yeah, so the other reason why we used our solution, which is paraffin wax and nitrous oxide, is because it has relatively higher specific impulse compared to solid solutions. But to be honest with you, if you were coming from a place where everything was possible, you would probably go for the solid route because it's just easier to work with. Nitrous oxide is notoriously difficult to deal with and very difficult to simulate. Especially when you're dealing with autogeneous pressurization, which is what we're trying to do. So yeah, but we'll see how that goes. We have some hot fire testing that we're planning to do in May, and we'll see how successful we are with that.
And very impressive. We chose to do our stage 1 hot fire campaign at the actual launch site. What we're hoping to look for is that the system responds.
This is actually pretty clever to do it at the launch site like this because it kind of helps you deal with some of the issues with launch because it's like literally the same infrastructure.
They all have to be able to rely on each other, and that's what we're looking for.
Definitely a smart way to do your hot fire testing.
It's all about testing the fully integrated system, all 9 engines on stage 1 together to validate the individual stage is ready to go into the full-blown campaign for static fire and launch. Ultimately, what we look for in acceptance testing is, do we have enough data to confidently say that we're going to be able to hit our flight objectives? We got the system health verification that we're looking for. It's been almost 3 years working on this program, and to actually see the completed hardware standing on the pad, it's very exciting. I'm very proud of the entire Relativity team. Quite frankly, it takes everyone across the company to be successful, and we had a bunch of folks across the company, from engineers, technicians, and support.
So H2O2 was actually another liquid oxidizer that we were considering. But the problem is that it's not self-pressurizing, which is the nice thing about nitrous oxide, is that you don't need to have a pressurant in the tank. You could keep it pressure fed. With H2O2, you would need to have a secondary gas to pressurize it and then force it into the combustion chamber, or you could use a turbo pump or something. Turbo pumps are expensive, so definitely not an option for a student group, I would say, unless you have some crazy way that you're going to self-make it or something, or maybe you get a sponsor, could be an option as well. The other issue is that H2O2 is actually quite difficult in itself to work with. It likes to decompose into water. And if you don't treat it right, it will do that. And then all of a sudden you don't have propellant anymore. You just have a tank of water. So yeah, definitely it could be an option for a way to approach it. But I haven't seen an amateur rocket, at least in the European community, that used that as a method. Yeah, even if you just let it sit, like if you just have a hydrogen peroxide just sitting out at home, it will decompose. Like I have a jar of it that I bought like a year ago, and I can almost promise you that it's mostly water at this point. So yeah, basically the more it doesn't take a lot of decomposition to totally mess up your rocket too, because if you buy it 95% strong, which is very difficult to get, by the way, getting that purity is definitely expensive. If it just decomposes down to 70%, that's literally 30% of your rocket mass now that's useless. So you have to have instant peroxide. You can't just be storing it, What is interesting though, there are actually some professional rockets that are using hydrogen peroxide. There's a rocket group in the UK, I think they're called Aurora, and their rocket is using hydrogen peroxide. So Maybe when they launch, we can do a live stream on them and investigate a little bit more about how that system works, because I'm curious how they're actually addressing those issues. I'm fairly confident they're using pumps, though, to move that hydrogen peroxide. But it will be curious to see how they deal with the whole decomposition issue. Yeah, CO2 would work, but the problem with CO2 is that it's very heavy. So as a like pressure fed solution, like you're gonna have a lot of inert gas in the end that takes up a lot of mass. The best pressurization gas to use is of course helium, because it has it's so light, but it's quite expensive. So you have to kind of balance that a little bit too. Nitrogen would be a good option potentially for pressurizing an oxidizer, because it's kind of like, it's not super heavy, but it's also quite cheap. Very true. Yeah, nitrous oxide is technically a controlled substance. That's true. However, you can get it if you have a scientific reason to have it. So there's just like a special permit you need, that you're only using it for scientific purposes and not for drug purposes. You might get away with the nitro in your car excuse the best. Yeah. Yeah, that's true. Teachers do often use it. True, but again, they're using it for an educational, so that's considered a scientific reason for it to have. So they have a piece of paper that says they're allowed to have it, and they can show that to the police if they come. Yeah, but it's certainly not hard to get nitrous oxide. I think it's probably one of the easier oxidizers to get in terms of regulation and stuff. Yeah, you can also just go to the doctor. They have it too, right? If you know a doctor, maybe you could get them to hook you up, you know? Yep. Right now, again, we still see that the tank is full because we still see the clouds coming off the rocket. So I think they just never detanked. I think they just kept it full. That was their solution. A hydrogen rocket. Try a hydrogen water rocket. It'll self-pressurize with the reaction of sodium hydroxide and aluminum. A hydrogen water rocket. How is that? I don't really understand what you mean by hydrogen water rocket. So is it water that you're pushing or hydrogen? Because if it's a hydrogen water rocket, doesn't it not count as a water rocket anymore now that you're using hydrogen? What you can do, if you want to really like push the performance of water rockets, is you can actually pressurize the water rocket with different things than just air. If you use CO2, it's actually better because it's heavier, so you get more kick when the air comes out. If you use like a lighter element for that, like for water rockets, it's actually the opposite as it is for space. Like lighter is worse. You want to use heavier stuff for water rockets. Okay, so you're going to pressurize with a hydrogen. Well, I guess you could try to do that. It would be very dangerous though, and very difficult to manage. Like you have to create like a hydrogen feed system then. That's going to be tricky. Hydrogen doesn't like to stay inside of pipes. Yeah, if you put the water to high temperature, then it's not really a water rocket. It's considered a hot water rocket because now you're using the thermal properties of water to get extra thrust. And then you're probably not going to want to use plastic like the PET plastic for the water rocket anymore. Probably going to want to move to some higher temperature solutions. Yeah, if you do try hydrogen pressurization and you do manage to solve the whole filling it with hydrogen, you're definitely going to want to take some safety precautions. That's for sure. Have I ever looked into photonic propulsion? Yes. You can. Photonic propulsion is certainly interesting, but certainly not very powerful. And you're going to run into problems with thrust to weight. Unless you have some seriously high power photonic generators, aka lasers. So it can work for like long duration space missions, like where you're flying to like really, really far away, where you have to have it on for a long time. But do you also run into a problem then with how you're generating all the energy to make all the photons in the first place? And then you kind of basically always end up at nuclear power. And that's obviously not really in the realm of conceivable technology that we have right now for space. Also a whole bunch of political issues with putting nuclear stuff into space. So yeah, photonic propulsion kind of falls flat because of that.
If you're just joining us, we are just under T-minus 33 minutes. We are progressing well towards our launch time of 1400 Eastern. If you missed the delay, the hour push was due to propellant conditioning. We wanted to get more time to continue that operation, and we're currently doing a great job. Everything is still green and a go for that launch time.
That is great to hear.
It's good to see that propellant conditioning is going well. I still would like to know what it means though.
Maybe let's take a moment to recognize the technicians that helped us build the rocket that you see on the pad today. We wouldn't be where we are today without all of you.
Yeah, so you saw the short with the Uncanny Man for the rocketry levels. Yeah, that was kind of a bit of a humorous take on, you know, the different steps you have as amateur rocketeers. Definitely not a hard rubric, I would say. I see we also have a Kerbal Space Program fan. Yes, Jeb is far more adventurous than us humans, that's for sure. Getting HTPB is impossible. It depends on where you are. If you're in America, I would say that making it is probably not that difficult. But yeah, if you want to get it elsewhere, it's definitely going to be hard because obviously it's a very high energy propellant. So not always that easy. However, there are some groups that are using it in hybrids in the European community right now. So it's not that it's impossible. I would not say impossible. I'd say very hard. There's a cool group though called High End. They're another German rocketry group. They operate out of Stuttgart, and they're actually building a rocket that's going to launch in a couple of weeks here, up from Kiruna, which is way up in Sweden. And they're building a rocket that has a fuel that's HTPB, and they're using nitrous oxide as the oxidizer. So it is possible for student groups to get HTPB. And we'll see if how that does. They're shooting to break the European rocketry record, which is 32 kilometers. So we'll see if they're able to get that. You wish you could have APCP. What is APCP? I'm not familiar with that acronym. That's one I don't know about. I assume it's a high power oxidizer. Like, is it ammonium perchlorate or something?
I think the coolest part of my job is that right now I'm getting to help design the machine shop for our next headquarters. And so that's not just copying the machine shop that we have now, that's thinking 5-10 years into the future and thinking, what are we going to need, and how can we improve what we have now, and how can we
it's ammonium
really spend the
perchlorate
time
composite
planning this
propellant.
out? And
So what is it? What is it? What is the composite propellant implying about the ammonium perchlorate? Just that like it's mixed up, or what's the deal there? I know that ammonium perchlorate is definitely the high power end of solids. So if you're looking to get high performance, that's definitely where you're going to end up at. Ah, I see. Okay. So you're using the aluminum as the aluminum is being mixed up in the HTPB. Got it. That's kind of basically how the SRB worked. Yeah, exactly. The SRB for the space shuttle. The key to that is making sure that your binder is smoothly mixed and you don't have any bubbles or air pockets. Especially when you're building a big rocket, that can be a serious issue. Yeah, we've actually done a lot of videos on different EU, not dedicated videos about EU rocket groups, but we've definitely done a lot of videos about that encompass many student rocket groups that are within the European community. So if you're interested in some cool entertainment on those topics, I would definitely recommend checking out some of our videos that showcase some of like the highest liquid rockets, some of the ones that show the future goals of student groups that are trying to shoot for space. A lot of them are European right now. Also, the Amateur Rocketry Awards, which is a video that we do every year that showcases all the biggest performances for amateur student rocketry enthusiasts. So it basically shows all the biggest achievements for all of the student university teams. Yeah, definitely check out that video if you're interested in the EU community, but also the worldwide community, because we showcase some American rocket groups as well. Yeah, it's definitely possible to use nuclear technology in space. That's unquestionably true. The trick is to try and make it so that, you know, the world's okay with you launching something that is nuclear into space. And also, you need to be launching on a rocket that's very reliable if you do that, because if your rocket fails, then we have a nuclear contamination spill wherever your rocket lands. So that's the issue with nuclear, right? It's kind of a safety thing. A political and a safety thing. But yeah, if you use, plutonium-238, yes, it's the safest, but still, try convincing the government authorities of that. Good luck. But yeah, if we want to think like interstellar, like this is what we have to do eventually, because chemical propulsion only takes you so far, and it's not to another star, that's for sure. And that's when you have to start thinking about higher power solutions. Yeah, the cost of this rocket. Actually, we have a nice little slide here that talks about the comparison of the costs for the Terran 1. Let me just find it here. Where did I put it? Here it is. So basically the cost for the Terran 1 is 12 million, which is pretty reasonable for the cost of the medium launch market right now. And it can get about 1,250 kilograms to low Earth orbit. To give you a comparison, Firefly costs 15 million, and it's like the cheapest that can do the same thing that Relativity can, that's listed right now. And it can't, the Terran 1 is a little bit more powerful than Firefly Alpha. but 20% cheaper. There are a lot of rockets that are in the 10 to 12 million dollar range, but they are for launching payloads that are much less than 1,250 kilograms. It's important to note, though, that if you look at the if you look at the tip of the nose of the Terran 1, it's quite small. So I think there might actually be some volume constraints on the Terran 1, which could potentially prevent them from being able to launch like a voluminous payload. So if like it had a whole bunch of small sats, I don't think it would be the ideal launcher. But for launching like, you know, dedicated satellites that are in that mass range, which is actually the majority of satellites these days, they're kind of falling around the, you know, 1 ton range. Yeah, I think it's a quite competitive vehicle. And they already have like, they say they have a 1 billion plus backlog already.
We have placed another hold on the T clock at T minus 24 minutes. We do need additional time for propellant conditioning. We're going to stand by for additional updates, and I'll send that to you as soon as I have them.
It looks like we're going to be at a hold here. Hopefully you don't push the clock back again. That would suck. We do have another hour and a half in the launch window, though, so keep that in mind. They could push back like another 30 minutes, and they'd still be within the launch window. I'm very excited for a manned mission in 2025. I certainly hope that they reach that ambitious time for making that launch happen. I'm a little skeptical, I have to be honest, especially if they're using the SLS infrastructure, which they will need to do in order to do this. At least if for NASA to achieve that. I don't think that's going to happen if it's with SLS, to be honest. If SpaceX decides, or if NASA decides to just use the SpaceX infrastructure to take people all the way to the moon, then maybe it's possible. But we'll see. I'm excited to see a Starship land on the moon. And I'm excited to see them put a ground camera on the base and we see the Starship vehicle land on a launch pad. That would be crazy. Oh, I didn't know it was a second anniversary of the Perseverance landing. That's actually pretty cool. I'm definitely a fan of the little helicopter they had on it. What was it called? Man, I'm blanking. Ingenuity or something? Something like that. I think it was Ingenuity. But yeah, the first flight on Mars took place on the Perseverance rover, so yeah, Ingenuity. It is Ingenuity. Definitely a engineering marvel to be able to fly on Mars, because you have to remember that the density of the air there is like 1% of that on Earth, so that's pretty insane. It's already hard enough for drones to fly on Earth, so the fact that they made it fly on Mars is truly exceptional. But yeah, in general, yes, I am excited for things that will happen in 2025. I'm not sure if we will get a moon landing though, but I hope we do. What I'm really excited for is seeing humans land on Mars. I think that's going to be a pivotal moment in space exploration and our development as a species. That's going to be basically what really kicks off the development of space in the future, because until as long as we're stuck on this planet mostly and we don't have development elsewhere, like it's really kind of stopping us from being able to expand and learn more about the universe that we live in, because you can only learn so much stuck on this rock. You gotta get out there. Yeah, that's the trick of it, right? Like there are so many limitations on developing a helicopter for Mars, and one of them is, of course, that the rotors you shouldn't spin them faster than the speed of sound, because you get a bunch of weird characteristics that happen. flow separation and such, which wreak havoc on a vehicle like Ingenuity. But yeah, the key is to make it light. Like that little helicopter they have is so light. It's all made out of like carbon fiber and like the really strong strength to weight materials in order to make that happen. Yeah, I hope we'll be alive to see the humans landing on Mars. But we have to kind of be part of it too. That's an important part of this. Like there needs to be support for this, otherwise it won't happen, you know? And one of the key ways you can try to be part of the support process is to get your local government inspired about these types of things, because usually it's the government that leads the way on these things, because that's where the funding is. So we want to stop the constant iterations of NASA's budget getting cut and things like this, because that is going to be what allows these companies like Relativity and SpaceX and you know, Firefly and all these other companies that are developing right now, like a lot of them get contracts from the government. And so when the government's you know, budget gets cut, they have to cut some of these cool ideas. And we could be missing, you know, the 3D printer that can fly to the moon and build structures, just because, you know, we decide that, oh, we're not interested in it anymore. The team that tried sending up discs by firing lasers underneath. Oh man, is this going back to like the 60s and the 70s? Because that's what it sounds like. Or is this Space Shot, Breakthrough Space Shot? I'm not sure where that went. It's still a great idea to use lasers to send things far out in the solar system and into potentially on interstellar trajectories. Because if you have a laser with just modest power, like you know, up into the megawatt to gigawatt range, if you have like an array of them, so you can be continuously shooting that at something, you can definitely push some sails to some pretty crazy speeds. The key thing that you have to think about though is like, how do you power the lasers? So you'll need to have like some crazy infrastructure on the ground to power all that. But once you get beyond that, like it's just a matter of building sails to be able to handle it. And the sail technology is like, it's been demonstrated on orbit already. We've built sails, we've had them perform functions in low Earth orbit. So it's just a matter of figuring out how to get the lasers to work. Yeah, Space Force. Yes, they're actually a commercial company that operate out of Poland, and they are building a paraffin-based hybrid motor. Yes, we're familiar with them. We've actually met them at the Space Tech Expo in Europe this past fall. They definitely have some cool stuff. I'm not sure when they're launching though, but they're also building a hybrid system, and it's quite a lot bigger than ours because it's designed to launch like, you know, commercial payloads onto these suborbital trajectories, so they can get like some 0G, get some space rating, stuff like that. Definitely interesting. Yeah, I would love to be alive for when they send back pictures of Proxima b or something like that. I think that we should, as a civilization of humans, I think we should devote ourselves to trying to explore out to other star systems, because like we really need to, I think we need to learn more about the universe that we live in. And it would be a mega project, you know, like it would take, I think it would take the entire world working together to be able to achieve something like that. But one way you could do it, potentially, would be with lasers. That's definitely, I think, potentially the most feasible idea, because all the technology exists today. We don't have to actually invent anything. We just need to, you know, figure out how to put it all together. The physics works. Yeah, the Space Force is certainly an avenue which can help the funding problem for space applications, that's for sure. So it'll be interesting to see how that develops and where their funding ends up going. That's a little bit of a secretive branch, though, of course, because and you have to have special clearances to be able to use that funding. So only certain launch companies can actually even launch a secret payload. I think it's like ULA, SpaceX. I don't even know if anyone else is allowed to yet. But I think Electron is the Rocket Lab is trying to figure out how to get into those launches as well. Yeah, a little bit secretive might be an understatement. Yeah, usually on those launches they don't even let you see the, like they make the launch providers not show the second stage because they don't want you to know where it's going. But if you're a clever astronomer, you could probably figure it out. They all make radio signals, and you can track them. So we're still in this hold here at 24 minutes. They haven't given us any other information about whether that's going to progress or what the plans are. What is clear though is that they're still keeping the methane and the oxygen in the tank, because we still see those clouds that are coming off the vehicle, indicating that liquid oxygen is being vented. And we also see that the flare stack is still flaring methane. So that seems to indicate that they're still keeping the vehicle fueled. So they could give us a new T0 time and launch the rocket, but we're not sure if that's actually going to happen. Yeah, the cloud's not moving enough. Maybe it's just a CGI image that they're showing us. It's not even real. Yeah, whenever the Space Force cooperates with SpaceX, it's like, you know, super secretive. It's even secretive within SpaceX. Like, only the people that are on the mission actually know, like, what the details are. Like, other people in SpaceX that are working on other stuff have no idea. So it's very, like, compartmentalized. Like, only the people that need to know actually do know. Oh, here we go. We might get an update now. Looks like we're at 50 minutes.
Holding the clock and taking it back once more. We just coordinated for a new T0 time with the range. Our new T0 time is now 14:40 Eastern. That is 2:40 p.m. Eastern. We're going to allow a little bit more time for propellant conditioning. As some of you may know, this is not at all unusual for a first launch. This is perfectly expected since we want...
Oh man.
Perfectly expected since we want all systems to be as perfect as possible before we do this.
Yeah, it looks like they're pushing it back. So it looks like we're going to have another 50 minutes or something like that. Yeah, 50 minutes more until we see till the T0. Still holding for propellant conditioning, whatever this means. I think it just means that they're, you know, filling they're continuing to fill and hold the propellant in the tank. Probably having to do with like pressures and, you know, whether they're liking the pressure values that they're seeing in the tanks and stuff. Remember, they've never actually filled the vehicle with the first stage and the second stage at the same time. So there are things that can happen that they don't expect because of all that. So yeah, we'll see if they actually end up being able to launch today. Although I'm thinking that at this point, because we have been pushed back so much, like the chances of a launch are going down. Yeah. We still have 2 more hours left in the window though. So the window lasts until, let's see, when does the window launch? It lasts until 9 p.m. UTC, which is 2 more hours from now. So we have 2 hours left in the window. Yeah, with the thing with the thing with launch vehicles today though is that there are a lot of them right now, and they're not all going to survive. There's going to be some competition, and I think and some of them are going to not quite make it. It'll be curious to see if Relativity Space's 3D printing is a solution that actually makes stuff cheaper in the end though. Right now it's not so much cheaper, just because like there's a lot of energy that goes into making a 3D printed rocket, because you're literally melting like all of the aluminum to reform it into the shape that you want, right? So in terms of like scaling up, it could be difficult to justify that as a proper manufacturing technique. But for everything else you can do in space, I think that the real business that they have here at Relativity Space is actually the 3D printer. And building a rocket with it is kind of a good way to verify and justify that, you know, this technology is just as strong as if you were just using regular metals. Because essentially, I mean, a rocket launch is pretty much the most extreme environment you can put those metals through. Hello, Emmett. Good to have you in the chat. Yeah, so the launch site today is Cape Canaveral, and it's at Slick 16, which is one of the launch pads there at Cape Canaveral. It's yeah, it's kind of an old one, so it was used a lot in like the 60s and the 70s, not so much in the last 30 to 40 years. It's just recently that Relativity picked up that spot and have been building their stuff there. So good to see the launch site back in action. Have you ever looked into the X-37B? Yes. It's a very cool plane slash spaceship slash whatever it's supposed to be. It's kind of like a space shuttle, like a mini space shuttle. It behaves a lot like the space shuttle. So far, SpaceX has been launching it. It's unclear what it does in space, though, because basically SpaceX launches it, and then it goes, and then everything else that happens is completely classified. But I suspect it's probably for reconnaissance. So, like, going and flying and, like, meeting other things in orbit and, you know, servicing them or maybe destroying them. It is a military vehicle, after all. Yeah, I don't know if Elon has need of their printer just yet. I think that what maybe would be more realistic is that companies that want to build structures in space will definitely start thinking about utilizing these printers. I think Elon's been pretty clear that he just kind of wants to build the highway system that goes out into the solar system. He doesn't necessarily want to build the infrastructure that is, you know, being put across the solar system. So I don't know if he would be wanting to buy the 3D printer. But you never know. He's a pretty erratic guy, so anything could happen. Yeah, do we use RF power amplifiers for long distance data transfer? Yeah, the short answer is no. We actually are not really relying on RF to transfer telemetry data. Like, telemetry data is not really the main mission, I would say, of our vehicle. So we're not gonna like make major modifications to our system in order to communicate across vast distances. So in the case of the launch to space, like, we're going to lose telemetry from the vehicle for sure. And that's fine, because if we recover our payload, we should have all of that data stored in the payload. In terms of the trajectory data, we're going to use like on-site radar in order to track the vehicle. So that's going to tell us like how high we went and, you know, the velocity, the accelerations and stuff like that. I'm sure. Yeah, I'm sure if you can market the 3D printer as a cool thing, I'm sure Elon will be into it. I'm not sure what he would want to print though, because it's pretty clear that like he has no intention to use a 3D printing process for the SpaceX Starship vehicle. Like that's something that he's building out of metal that's going to be welded together. I don't think he really has an intention of 3D printing the structures of that vehicle. And it's already quite mature, that design. So doing a 180 on that now would be kind of weird. Yeah, so right now we don't really know how long it'll be till the launch, to be honest. Right now it's T minus 44 minutes, but that has been, of course, delayed a couple times already today. So keep that in mind. It is a practice launch, a test launch. So it's not necessarily as reliable in terms of the launch time. We do have a window though, and there's 2 more hours left in the launch window. So it could happen any time in the next 2 hours. Why will we lose data? Good question. I believe 2 watt, like a 2 watt power amplifier, I think is enough for 100 kilometers distance. But the question is not so much like, is it enough? So much as how much data can you transfer with that power? So as you go further and further, your link budget gets worse and worse and worse. And so depending on how much data you want to transfer, it determines whether you're actually able to pull off the telemetry. The problem is that as you go out to 100 kilometers, like your link budget gets kind of bad with low power. So unless it depends on how much transfer rate you want. So like if we just said, okay, in the end, basically we're going to prioritize altitude data. So altitude data will go down first. We might not lose that necessarily, but we'll definitely lose packets of some other data that we have that's just too much, right? We're going to be collecting data on like the 100th of a second time frame. And so transferring all of that down to the ground like immediately is definitely not going to be as reliable up at 100 kilometers. But I don't think that should be something like if you're trying to build a telemetry system for a rocket like that, I don't think you should prioritize that, because it's nice to have that telemetry data immediately, but it's far more useful to get all the data and recover your vehicle. Like then you have everything, especially if you want to put like video on there and stuff like that. Like there's no way you're going to like use telemetry to stream video. Like you would need crazy amounts of power for that. Yeah, the countdown is on the top left in case you want to know, but please take that with a grain of salt. The vehicle has been going through lots of holds so far, so you know, don't get too excited if it looks close to launch. They might hold again. What's the status of Transcendence? Well, we're actually doing Transcendence in 2 phases now. So first we're going to build a smaller rocket, and then we're going to build a big rocket. The smaller rocket, which is temporarily called subscale, that one is, for all intents and purposes, mostly complete. We just have a hot fire test that needs to happen in May to verify that the propulsion system is working, and then basically all the components are there. We just have to assemble them. And that's the rocket that we want to launch this fall at UROC. And it's just going to fly to 3 kilometers, but it's going to be very similar to Transcendence in terms of its architecture. So it'll basically be verifying all of the the propellant loading, the tanks, the bulkheads that we're using, all of that kind of stuff that is, you know, weird and novel about Transcendence will be verified with that subscale launch. And then after that, it's just a matter of building all the parts again, which, if the small rocket launch works, should be relatively straightforward, because we essentially just build the same vehicle. We're just stretching the tank. So the oxidizer tank gets longer and the combustion chamber gets a little bit longer as well. So it's just a matter of, you know, winding a longer tube, which is really a trivial problem compared to all the other problems we've had so far. So yeah, that's kind of the status. Once we have our hot fire in May, we'll definitely know way more about what our capabilities in terms of launch are going to be. But right now we're targeting Transcendence launch sometime in the spring to summer of 2024. Yeah, we'll see. I'm not sure what you mean by sending up a balloon with a repeater. Like, is that for like, for what purposes do you want to do that? A 40 watt power amplifier, enough for 100 kilometers real-time telemetry data transfer. It sounds like it might be, but I'd have to do the telemetry calculation. Like I'd have to do the link budget on it. And it depends on how much telemetry you have. Again, it's all about how much data you want to move per second. So like if you're only moving like, 1 kilobit, 1 kilobit per second, or less than that, it's probably a lot easier to get away with smaller powers. But if you're trying to move, like if you're moving video, like we're talking about megabytes per second, and that's definitely not something you're going to be able to do with just a little bit of power. I don't know, it depends. You have to do the link budget. I would recommend that you like Google link budgets and how to calculate it, and then you can see if you can do it.
Range for a new T0 time of 1440 Eastern. That is 2:40 p.m. Eastern. We did add this time to allow us to continue our propellant conditioning. We'll continue to provide you updates as we get them.
So yeah, we're still, they haven't moved the clock from when they came on before. It's still coming in about 38 minutes. Hopefully that will hold. Ah, I see. So you want to like put a balloon up just so that you can transfer the data to the balloon then? Or like how's that going to work? So like the balloon is like kind of like a data relay. I guess you could do that, but it does complicate things a bit. And I would assume that's why student groups probably don't do that. It would be cool to have a camera on board a balloon though, and watch the rocket like fly by. I don't know how accurate that would be, or whether you'd actually be able to capture the rocket on camera from the balloon. That would be certainly a camera challenge. Yeah, if you wanted to transfer 256 bytes per second of data. So, okay. I don't know. Again, you have to look at the link budget calculation. Let's see. I don't have it right immediately in front of me, but basically the way a link budget works is you're just taking like how much power you have, and you're dividing it by like how much distance you have to go by. So that's like your attenuation. You also have to consider the attenuation of the atmosphere. You have to consider the signal to noise ratio, because if you're in if it's relatively noisy area, you need like a higher signal in order to differentiate that from the noise of the surroundings. So it's only after you do that whole calculation that you can really say for sure that you're going to receive all the data. And although I am space engineering minded, telemetry is not my strong suit, and I can't do that calculation in my head on a live stream. So I apologize. But I assume that like 256 bytes per second seems doable with something in the range of like 10 watts of power. The other problem that we have with like data is actually you cannot actually get GPS data when you're at like 100 kilometers altitude because the US military actually restricts access to that information at those altitudes. So you have to actually unlock your GPS to be able to do that, and that takes like a lot of regulation and approvals. So that's why we're not so concerned about the telemetry as well, is that because we can actually more reliably rely on radar in order to determine altitude rather than we can actually our own sensors on board the vehicle, because we'll basically just be relying on the accelerometer at that point. You just did the math and the answer was shrug. Yeah, I guess that's it works then, right? So the reason why they're using methane fuel is twofold. So first of all, they want to use a fuel that gives them high specific impulse, because the higher your specific impulse, the more you can lift for the same mass of your rocket. So it gives you better efficiency. And the second reason why they want to use methane is because the rockets, the rocket engines they're using, the Eon engines, they are using the expander cycle, which means that they're trying to spin their pumps using the heat from the engine. So basically the methane goes through the nozzle, it picks up the heat of the engine and gets vaporized, and then that hot gas goes through the turbine and gives the turbine energy, which will spin the pumps. It's kind of like a regenerative process, kind of a circular regenerative process. And this only works for cryogenic fuels. So if you're using like RP1, you can't do that because RP1 doesn't behave that way. So the only fuels you could use for those situations would be hydrogen and methane. And hydrogen, of course, is very difficult to work with, and you need really voluminous tanks in order to contain it, because it's so it's really not dense at all. And I think that would be a challenge for their 3D printing technology. So I think this is why they settled on methane as their final solution for what they were going to use as the fuel. That's another good point. Yeah, it's not just the distance and the power. The antenna design is also another part of it. This is in the link budget equation. This is just represented by a single term, but in reality, it's like super complicated. There's all different kinds of like shapes and like distributions that antennas and transmitters have in terms of how powerful their signal is, like in their beam width and stuff like this. Yeah, it gets quite complicated quite fast. So yeah, sometimes you do the math and shrug really is the answer. Yeah, the GPS is certainly a problem. It's a problem for Transcendence especially. If Transcendence gets to space, what's next? Well, there are some crazy ideas in the pipeline. I'm not sure if we're ready to necessarily share all of them. We certainly haven't picked one yet, so maybe I can tell you a couple of ideas that we've had. One is that we want to maybe build a CubeSat that we would basically take a ride share and send into space. We're also thinking of potentially upgrading our recovery technology for the vehicle. So maybe we could have something that is fully recoverable. Right now, Transcendence is only partially recoverable. We just take the nose cone back. So maybe we want to try to launch it and recover the entire vehicle. We were also considering developing some liquid rockets. Of course, we have some experience now with designing a hybrid rocket, but liquid rockets potentially are more worth the investment of how much time you have to put into researching and developing than hybrids are, because with the liquid you get better performance, and of course they're kind of more applicable to the commercial launch sector. We also have even crazier ideas of potentially trying to do things on the moon, but we'll see. We'll see what we decide, what the team decides will be the next challenge for ASTRA. But first we have to get Transcendence working, and we still have lots of work to do on that. Yeah, you're definitely going to get asked the quadrillion questions if you're trying to get GPS unlocked. That's definitely going to happen. That's just the reality. Because they're worried, right? Because essentially if you have an unlocked GPS that is flying up to over 100 kilometers altitude, you essentially have all of the tools you need in order to build a long-range missile, right? Because with that data, you could have like targeting software, and yeah, that's where you get into the place where it's like, well, is this a weapon? Kind of an issue. Yeah. Well, I'm surprised. So I'm surprised you went through the whole process of answering every question. I don't think I would have the patience for that. But I'm sorry that they denied it. But that is typically how it goes. Unless you're a commercial entity that has like a commercial reason for doing it, usually they are not excited to give that data out. Why no super chats? Well, I don't think our YouTube channel is monetized, so this might be the reason why we don't have super chats. But if you are interested in donating to ASTRA, you can through the website or through the link that's in the description of this video. So if you just open up the description, there is a link to, I think, a PayPal donation page. So if you do want to support the ASTRA team, that is one way you can do it. We are actually launching a crowdfunding, a big crowdfunding campaign tomorrow. But the details of that are definitely on our website, if I'm not mistaken. You can tell that marketing is not really my end so much. How big are the 3D printers compared to a school bus? Probably like a third of a school bus, I would say. That's what it seems like based on the pictures that they've shown. Like they're about, I would say, 2 or 3 meters in diameter and like 3 or 4 meters tall. So yeah, that's like a third of a school bus, I would say, roughly. The trick will be seeing if that can fit into a rocket. That would be cool. Yeah, they even asked about your grandfather. This is for the GPS unlocking again. Yeah, they got to make sure there's no issues with your family members as well, I guess. Because what if they steal your GPS? Then they could use it as a weapon. Yeah. The military is really anal about that. What would be interesting is if a commercial entity decided to just launch a GPS constellation of their own, and then anyone could just get a GPS signal if they just paid this company. It could be a future thing that would be a really good market opportunity. But I feel like the people that would be using that would be very specific and not big enough maybe to justify that, because GPS already covers most things. Yeah, I would say that the school bus is not necessarily the typical American measurement. It's probably the football field. That's probably true. Unfortunately, American football fields are different than European football fields because we measure them in meters instead of yards. In case you want to know how big Relativity's Terran 1 is in terms of football fields, it is about 1/3 of a football field long. Yeah, meters and yards are similar enough, but unfortunately it creates complications when you're trying to order parts from around the world. And some manufacturers ask for your units in inches and feet and things like this. Sometimes it can be a bit annoying. So it looks like we're still doing propellant conditioning, whatever that means. But we are getting some bigger clouds coming off the vehicle. it looks like. I'm not sure if that means anything. Maybe it means we're getting a bit closer to launch. The clock is at T minus 24 minutes, which is where they held last time. So if we get past this point, then we're a little bit further. Yeah, 18-mile-per-hour winds aren't usually too much of a problem for a rocket. You have to remember that, like, for amateur rocketry, like 18-mile-per-hour winds would be definitely annoying, because as soon as your rocket comes off the launch rail, it basically will point towards the wind. And if you have such a strong wind, it has a much higher, steeper vector pointing towards the wind. But the thing is that for a commercial rocket like this, it has engines which can gimbal, which means that they can compensate for that.
Just joining us, we are currently at T minus 23 minutes. If you recall, we did set the T clock back a little bit in order to allow for propellant conditioning. You might also be able to see that the clouds are coming in. Our team is keeping a close eye on the weather right now, just because we want the maximum visibility that we can get for this historic first launch. We'll keep you updated along the way.
Oh man. Looks like they care a bit more about the weather than than I did. Of course, we do want to make sure that we have nice tracking of the vehicle as it flies, so sometimes clouds can be a problem for first flights. But as I was saying before, the wind problem at the surface is usually not a problem because the gimbal on the engines is more than enough to compensate for the extra force that the vehicle has from the wind. So the vehicle won't like point to the wind.
Director Clay Walker in Mission Control. Let's listen in for the next few minutes.
So it looks like we might be close to some go, no-go polling. We will see. The bigger problem for rockets like this in terms of wind is actually the upper altitude winds, because like rockets are like these long, skinny pieces, and so when they get up to like into the stratosphere at about 10 kilometers altitude, that's usually when they're going through the transonic regime and to the supersonic regime, and in that moment with a like a crosswind of like 100 meters per second or something, that can sometimes be an issue, and it can create too much force on the structure itself and actually tear the vehicle apart. So that's usually the wind value that they're looking for when you're talking about a commercial launch. It's cool if you're close enough to the launch site, definitely get outside, because you might see it take off. Especially if it's a clear day down there in Florida. Don't miss it. Wind is an excuse for being lazy. Well, kind of. Usually though, the wind is not the problem, right? It's the higher altitude wind that would be a problem. Lightning is kind of a controversial thing for rockets, because there have been, of course, like Apollo 12, like the one you mentioned, was hit by lightning and there are no issues. Although it gave the mission control quite a scare, because they were like worried that something was going to happen. There has been one rocket, and I forget which one it was. It's escaping me. It was hit by lightning, and it actually messed with some of the navigation software on board the vehicle, and it actually caused the mission to be a failure. It didn't like blow the rocket up immediately, but it just caused it to not reach orbit like it was supposed to. So yeah, usually rockets try not to launch during lightning. And usually when there is lightning, it's indicating that there are other weather problems that are going to be an issue for the vehicle. Yeah, thunderstorm is definitely not what you want to launch a rocket into. Yeah, it is a bit temperamental down there, that's for sure. Although, I would argue that, you know, at least it's nice down there. Right now in Bremen, it's like hovering around 0. And it's always cloudy. At least it's sometimes sunny in Florida. In Bremen, you basically don't see the sun for 6 months because it's cloudy like all winter. Yeah, well, I guess we all have different perspectives on what nice weather is. I would just be happy for some sun. But based on watching rockets launch from Cape Canaveral versus launching from Vandenberg Air Force Base.
I'm hearing now that we're expecting the go, no-go polls to occur in approximately 3 minutes. While we wait, let's talk about the nose cone that we have today.
3 minutes away from go,
So
no-go.
we don't have a customer payload on board, but we do have a memento inside of our nose cone. We have included our first ever 3D printed piece from our Stargate printer. And of course, it was a failed print since no one had ever done it before. As you see on your screen, that is our nose cone memento.
So this is
That
the payload.
6.5 inches in diameter and weighs about 3 pounds. It is our first completed circular test article for which we used our first generation aluminum alloy. Since then, we've added a machined centerpiece with GLHF, good luck, have fun, and our mitosis logo to commemorate this maiden launch.
From our very first failed.
So yeah, it's definitely glad that you like the videos and about the manufacturing and the testing and stuff. Yeah, developing a video about the avionics is always a bit difficult in some cases though, because to be honest, a lot of it is not super glamorous. But yeah, we definitely are overdue for an in-depth video about what's going on with the flight computer and what's going on underneath the hood of the Transcendence vehicle. But yeah, that ring, yeah, the ring that they're sending to space definitely looks like something you'd put on your car. It's not that big though. It's only like I think it's like 1.5 kilograms. It's like definitely something you could just like hold in your hand. But definitely cool they send that as their payload. I don't think ASTRA has even kept the first thing we built. But yeah, as I was saying, thanks for the prompting to do some more information about avionics. We definitely have underrepresented that in the group on the channel. I hope the no-go poll goes well. We're about 1 minute away from that, it looks like. I think they said it was going to be at T-minus 15. So it's the closest we've gotten to the launch so far. This could be it. Hello again. If you stepped out briefly, we're still at T-minus 15, so we're getting closer to potentially launching. It looks like the go, no-go poll is going to be coming relatively shortly. They said it was going to be at around T-minus 15, so we're just holding to see what's going on there. Totally understand if you didn't have the patience. But don't worry, you didn't miss anything too crazy. That's true. Each second we are getting closer. But usually if you get past the 15-minute milestone, that's a good sign.
FTS go.
FTS go. RF.
RF go.
RF go. GNC.
GNC go.
GNC go. Flight software.
Flight software go.
Lights off or go. Prop 1.
Prop 1, go.
Prop 1, go. Prop 2.
Prop 2, go.
Prop 2, go. Fluids 1.
Fluids 1, go.
Fluids 1, go. Fluids 2.
Fluids 2, go.
Fluids 2, go. Loads.
Loads, go.
Loads, go. Rock. Ranges, go. OSM.
OSM is go.
OSM's go. RC. RC, go. Vehicle.
Vehicle is go.
Vehicles, go. CE.
CE's go.
C's, go. LC.
LC, go.
All parties have reported go for launch countdown.
We are go, guys. This
Once
is
the T-clock
amazing.
begins, anyone can call for a hold at any time. If a hold is called prior to T-minus 70 seconds, the T-clock will continue to roll until
All
T-minus 70
right.
seconds.
This is looking
At
positive.
which point a hold will be automatically initiated. A hold is not possible after T-minus 70 seconds, and any hold call after that time will result in a terminal count abort. Should a hold or manual abort be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that the OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and the RC on the primary net.
Okay, so basically the rules are now if
LC, CE on Bravo. Can we open stage 1 fuel bleeds, please?
if we hear the hold, they'll go to a hold again, unless it's in the last 70 seconds.
GCDC, please limit comms channels to Alpha, Bravo, Charlie, and countdown unless directed by the LC or LD.
If it's in the last 70 seconds, it'll just be a straight abort. So yeah, machine learning and space technology is certainly something that has been done.
You just heard our launch director complete the go, no-go polling with our mission control team. All systems, as you heard, are currently healthy, so as of now, we're able to proceed with our scheduled launch time in about 12 minutes.
Throughout today's live stream, you've been hearing callouts for mission control. Let's take a moment to introduce you to our mission control team. Clay Walker, launch director. John Wiswall, launch.
So basically, the space technology that gets the machine learning technology that gets incorporated into the space sector usually has to do with designing these 3D printed parts. So of course, with 3D printing, you can create all kinds of crazy shapes. So you can kind of reduce the mass that you have in order to achieve some sort of structural aim. But it only kind of works with 3D printing. Keep that in mind.
Operations, Pat Svatek. These are among many, many others who are making today's launch happen.
All right, so we're coming up to T-minus 10 minutes pretty soon here.
For those of you that are just tuning in, you can see Terran 1 on the pad. This rocket is 85% 3D printed by mass. It is 110 feet tall and 7.5 feet in diameter. Stage 1 has 9 Aeon 1 engines, and our second stage has an Aeon vacuum engine. These engines are also 3D printed using powder bed fusion. We're going to go ahead and take a moment to pause and stay tuned as we wait on the launch countdown.
Yeah, is this good knowledge for our team to watch other launches? I would say in terms of like the operations of the launch, maybe not so interesting for student launches, but in terms of like getting inspiration from commercial companies as to what we do to solve our problems, I would say definitely. Just the fact that Relativity Space exists and is trying to 3D print a rocket like this, that definitely inspires us to try to think down that line and think, okay, maybe there's a way we can solve one of our problems with 3D printing. So I would say that in that sense, it's good to keep appraised with what's going on in the commercial sector.
We are getting extremely close here. Our countdown sequence will begin in T-minus 10 minutes, so just 30 seconds away.
Maybe the rocket's going to fly right through the clouds, just like poke through the hole. We can have a clear shot from the ground. I really hope that the clouds don't block the view from the ground. That would suck. Yeah, 3D printing is definitely the future. They will definitely be used a lot in space in the future. There's no question about that. And that's why I think Relativity Space is going to be
minutes, countdown sequence has started.
certainly a company that survives. Whether it's good for making an entire rocket like this, maybe that's a bit questionable, but the technology is certainly highly valuable.
We're currently at T-minus 9 minutes and 40 seconds. In the upcoming minutes, you're going to hear several call-outs from Mission Control as we go through the final pre-launch procedural steps, including
could
the
certainly-
priming of the igniters, final engine checkouts, transporter erector retraction, and getting that final go for launch. Again, we're now pressing the tanks to flight pressures, and we're currently proceeding with our scheduled launch time.
It would certainly be interesting to see a 3D printer that could print a Mars home. And there are different ideas for how you do that, but the technology that Relativity Space is one that definitely could potentially fit inside of a rocket.
We'll be looking for a call out
So
in the next 30 seconds that stage 1 is transitioning to helium.
all the other ideas have been far too bulky to fit into a rocket. Yeah, to be honest, SpaceX has been exponentially increasing their launch count for the last 10 years, so I wouldn't surprise me if they managed that. The double the launch count. Right now they're hitting about 60 launches a year. I'm sure they're going to be at 100 by 2024. Yeah, the smoke coming off the rocket is just liquid oxygen. It's vaporized oxygen at that point, but it's to keep the oxygen in the tank liquid
Transition to helium.
without over pressurizing the tank.
There you go. That means we're pressurizing the propellant tanks to flight pressures.
For engine chill.
The engine chill is basically when they just run some cryogenic fluid through the engine so that all the parts are
We'll
cold.
be charging these stage 2 igniters to flight targets in just about 10 seconds.
If you don't do that, then you can kind of cold shock the engine, which can create structural issues. So it's an important step. It does sound quite windy down there on the ground, though. You can kind of hear it droning on in the background. A 3D printing on Mars could be a good thesis topic, for sure. Certainly a very expansive one. The trick is to figure out how you're going to get the materials there to 3D print.
We are now getting into the business end of today's countdown.
Pressing stage 2 igniter to flight target.
Arwa, let's go ahead and walk through the launch timeline.
Yeah, sure. At T-minus 3 minutes, the transporter erector will retract just a few degrees to give the proper angle for umbilical separation. At this point, the vehicle will be on internal power. At T-minus 70 seconds, the vehicle will go into terminal count. This is again when the vehicle's internal flight computer takes control of the countdown. We then go into final flight termination checks and get FTS go from the launch conductor in coordination with the mission flight control officer and operation safety manager. At T-minus 6 seconds, we'll have ignition of those 9 beautiful 3D printed AON-1 engines, so you'll see the flames beneath the rocket at that point. And at
those engines look kind of
T0,
weird.
we will have liftoff.
That stuff
Shortly
that's all
after
around
that,
the
at
engine
T
is
plus
like
2
insulation.
seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly vertical. At T plus 12 seconds, we'll begin our pitch over program, and at T plus 80 seconds is that important milestone of max Q, or the point of maximum dynamic pressure. This is again where the structural loads on the vehicle are the highest, making it one of the more challenging phases of flight.
At approximately T plus 160 seconds, we'll have main engine cutoff, or MECO, where the stage 1 engines will shut off, followed shortly by stage separation and the AON vacuum engine igniting. Second stage will burn for a little under 5 minutes. And then at approximately T plus 463 seconds, we'll have second engine cutoff, or SECO. As a reminder, we do not have a fairing or any payload deployments for this first launch. With that, we'll go ahead and wait and stay tuned with Mission Control.
And once again, we are so honored to be hosting.
So yeah, metal 3D printing on the moon and Mars would not have to deal with oxygen. That's a good point. It would definitely, certainly, potentially increase the quality of the print as well. There's also another industry that's kind of developing a little bit, which would be in space manufacturing, where you can kind of build some things in space that you couldn't on Earth. And one of the things you can do in space, of course, is not deal with oxygen. I'm not sure which PCBs we actually use, which material we're using. I would have to ask my avionics lead about that. But yeah, we do make a lot of PCBs these days. I feel like we're producing quite a few. They're quite cheap to do, so I'm assuming it's probably the cheap one, to be honest. If I was going to guess, it would probably be the cheap one. Yeah,
Stage 2 is on internal power.
We're spending on the order of like euros.
You just saw the transporter erector
PCB.
cradle disengage.
The cradle's disengaged.
There we go. The cradle arm slowly started releasing stage 2 at the top there so that the strong back camera tracked, and we confirm that stage 2 is now on internal power.
Okay, we're in the last bits here. Once it gets to the 70 seconds before the launch, then we're in the critical phase where the vehicle takes over the operation. And at that point, if there's a hold called, we will it'll be an automatic abort. So we'll be in the final phases here. Just to reiterate, we're actually not...
Stage 1 is on internal power.
There is no fairing deployment in this launch, so if you don't see that, don't worry. It won't be a failure.
Stage 1 TVC checkout complete.
Do I trust Chinese manufacturers? Well, there's nothing
we
we
just
really...
completed stage 1 TVC checkouts. That means that we performed the final...
There's nothing we really do that's like proprietary, so in this case, and at this point, it doesn't really matter, and we have no problem buying from the Chinese. But I mean, if you were going to build a commercial vehicle where you wanted to hide your technology, you might want to not go down that route.
Checkouts.
It could be a bit dangerous. But yeah, right now we just care about cost. So whoever gives us the cheapest PCB, that's what we're gonna buy. These engines look crazy. Like, I think all that packing around them is the insulation.
Next step will be retracting the strong back,
but I'm
and
not
then
sure.
our range coordinator will ask the range for their status one last time.
Everything seems okay. We're almost in final count. That's going to start at T-minus 110. That's when the terminal count starts.
Rock report range status.
Range green.
Range is still go. No one's in the way.
And that was confirmation that the range is green for launch. We are almost a minute away.
Looks like we held at 109.
Announcement on countdown net is the LD. We are holding
Ah,
until
shoot.
70 seconds prior to terminal count to address issue.
All right, you heard Clay Walker, our launch director there. We are holding at
Strong
T-minus
back retracting.
69 seconds to address an issue.
They
We
held.
are, however, at the same time retracting our strong back. That black truss structure there is the strong back. It'll retract just a few degrees to prepare for umbilical separation.
So they held right at the
We'll
start of
stand by
terminal
for
count.
further updates from mission control, and we'll update you on the hold.
If they would have let it go for another couple seconds, it would have caused an abort. So it looks like we didn't quite get the terminal count, according to their definition. Okay, this is like the weird gray area. What does this mean? No, this rocket is not going to land like the Falcon 9. It's an entirely expendable vehicle. So it'll just be falling into the ocean. But keep in mind that Relativity Space is looking forward to doing recovery for the Terran R, which is going to be the next vehicle that they're going to be developing. It's a lot bigger, and it's looking a little bit like a starship, like a little bit of a smaller starship. And their goal for that will be to have it be fully reusable. But first, they just want to figure out how to get a rocket to space. So that's kind of the purpose of the Terran 1. Yeah, there is a lot of pressure on them, I guess. I think it's always a little bit jittery with the first launch because, it's like if there's any little tiny problem, you're like, okay, you don't want to launch because obviously.
As a reminder of what our launch director said earlier, this is the last opportunity that our team can call a hold. So the team chose to take that option at T-minus 70 seconds and ensure everything is nominal before we go into our terminal count sequence.
I kind of suspected this was the case. So I think nothing was wrong. They just did the hold anyway, just to
Again, what
have
you're
extra
looking
time.
at in
Sharp
front of you
retracting.
is 85% 3D printed, and it is about to fly. Those white clouds you see coming out of the rocket are due to the venting of the chilled gas from the rocket into the humid Florida air out here. That's why the gas condenses into
the nose
vapor
cone
and
behind
looks
me,
like
it's
clouds.
just getting warped by the camera frame, but it's just a normal nose cone. It's made out of fiberglass. But yeah, don't worry, it's not like a weird shape. It's just the camera lens warping the shape. There you can kind of see what's going on. But yeah, it's actually pretty cool that we were able to build that because it's like really, really strong. We've already tested it to quite extreme extents. We dropped it into the lake a couple of months ago from a plane, and it hit the lake at 2 times the velocity we were expecting, but it still survived.
I'm hearing
no
that
problem.
our T-clock will resume in about 1 minute.
Okay,
Announcement
so
on countdown, this is the LD. The T-clock will resume in approximately 20 seconds, transitioning to terminal count.
okay, they just did the hold just to make our hearts all stop. Trying to amplify the drama. Okay.
As a reminder, from here on out, when the T-clock resumes, our countdown sequence will be automated and controlled by the internal flight computer.
All right. So yeah, now they have no time. There's no period between. Like it'll go straight to terminal count now. They're not going to put the clock back. So it seems. This is the thing about these big, long launch windows is that they can kind of do whatever they want in between. So you never really know when the rocket's going to launch. When you have a payload, you usually have an instantaneous launch time, especially if you're going into a high inclination orbit. So they can't really do this so much. Yes, I know the issue with touching fiberglass and the whole having fiberglass on your hands. Trust me, there's far too much fiberglass in my clothing than I would care to admit. Yeah. It's just one thing that I've kind of gotten used to after working with it for the last year. I much prefer carbon fiber. Fiberglass comes apart a lot easier, and it almost makes smaller particles when it breaks apart, and it's just far more annoying to get rid of. But yeah, we try to keep the fraying bits of the fiberglass covered with tape in order to reduce those problems. This one was made a couple of weeks ago, so it hasn't been painted yet, which usually tends to also reduce the fiberglass problem.
We are extending the hole just a little bit longer. We're going to stand by for further updates from Mission Control.
I hope it goes now. They said it would go in 20 seconds. I guess they're taking a bit longer.
announcement on Countdown Net is that LD, we have had a terminal count abort, saving the vehicle and assessing recycle options.
Recycle options. That doesn't sound good. I think they found a problem. The idea to roll tape over your skin to pull out the annoying itchy spots, I think I'm going to try that next time. See if it works.
You heard that announcement from our launch director. We're going to have an update momentarily as to what happened with our automated abort.
Shoot. Yeah, carbon fiber is more expensive. That wasn't necessarily the reason why we chose to make the nose cone out of fiberglass. It was more to do with the radio transparency. Carbon fiber is not really radio transparent, so it was smarter in the end to build it out of fiberglass. And you don't really lose too much strength with fiberglass. It's only about like 20 to 30% less strong. So you can get kind of to similar levels of strength with just a little bit more mass. Baby powder before working with fiberglass, another good idea. We might have to try that one as well. Yeah, it looks like they're probably going to be in an abort at this point. They said they would discuss recycle options, so they might come to the place where they decide to try the count again. They do have another hour in their launch window, so.
If you're just joining us, we did have an automated abort at T-minus 70 seconds. The team is currently assessing if we're able to recycle since we are still within our launch window. So we'll provide that update as soon as we have confirmation from Mission Control.
Yeah, depending on what the error was. So they obviously have to figure out why the vehicle put it into an automatic abort. If they figure out why, then they might be able to recycle. But if they need like more time to figure it out, then yeah, it's probably going to be an abort for the day. Yeah, I mean, they probably needed a final test day, to be honest, because I don't think they've done a full up fueling of the vehicle like this yet. So, but we never know. It could be still a launch. They still need to. They could come back and the automated abort might be a simple issue or a glitch. But yeah, they have grabbed back onto the rocket. So I think they had to do that anyway because they have to keep fueling it. They can't have it, like if they just leave it on the pad, it'll slowly leak all of its oxygen and methane. Yeah, the nose cone isn't pointy. This isn't really like the nose cone for the final vehicle though. Like they will have a fairing if they have a payload aboard. The thing is that right now the payload is just their little 1 kilogram mass, so they can basically just put this little stubby nose cone on it, and like that's enough. But yeah, pointy is definitely better. It was really rough of them to tease us like this, with the clock so close to the launch time. Like, just give us a couple more seconds. Yeah, when we're simulating the subscale vehicle, so the smaller rocket, we will use open rockets. That is the one that makes most sense to use because it's quite reliable for subsonic flight. But when we're dealing with supersonic vehicles, open rocket is, I would say, less reliable. So we actually switched to ASTOS, which is a software that you can use to simulate trajectories. We have a sponsorship with them, so that's why we're using it. And it's quite good at modeling like a flight from anywhere from subsonic to all the way to orbital. Yeah, it's called ASTOS. It's a proprietary software. It would cost like thousands of dollars for a normal person to get their hands on it. We just are lucky enough to be sponsored, so we're using that for our purposes. It's more of like a commercial software. It's used a lot for like actual rocket launches and satellite stuff. Yeah, Astos Solutions is the company. I'm not sure on the exact cost, to be honest, but it's definitely outside of the range of normal amateur activity. I can assure you of that. It's more aimed at commercial customers. But there are a bunch of other trajectory softwares out there that you could try out, and you could also even try and build an in-house solution for this type of stuff as well. Like if you have a specific trajectory range that you're dealing with, you could maybe, if you're clever enough about the aerodynamics, you could probably build a model that's, you know, reasonable enough. Yeah. Especially if you have some wind tunnel testing underneath your belt, you might be able to get away with it. It gets a little bit tricky with getting up to 100 kilometers though. Then you probably want a better software. Man, they're really not good at telling us what's going on. My goodness. I guess that's to be expected for the first launch, though. I think the longer they hold us, though, the more likely they're going to try to recycle, because it seems like they're trying to fix the problem. Otherwise, they just tell us, yeah, it's a no-go. Man, that's a complicated question. How do they calculate PID gains for big rockets? What I can say is that it's a lot easier to control a big rocket than it is a small rocket, because you have to think that the gimbal on the rocket engine is way at the bottom of the rocket, so it's like really far away from the center of gravity.
Once again,
so
we
just
had an automated abort at T-minus 70 seconds. Our launch director and our teams in mission control are currently assessing the recycle options that we have for today, since we're currently still within our launch window. We're standing by to hear that update from Clay Walker.
Yeah, so still no update. But yeah, back to the PID gain question. Because you have such a long lever arm with the rocket gimbaling on the bottom, it's actually quite a lot easier to control the movement of a large rocket. So just a really small gimbal can create a large force in the transverse direction, and you can actually keep your oscillation relatively minor for the entire rocket launch, just with a very modest rocket gimbal. You can even do crazy stuff like have the thrust off center, so like space shuttle, you know, like there the thrust was literally off the center of gravity. And because the rocket could gimbal, you could actually compensate for that and still have the rocket go up. Yeah, for the ASTO Solutions software, you do need a reasonable PC to be able to run it reasonably. It was definitely on the edge of some of our laptop's ability to run it. So, but I don't think it's that bad. There's definitely other software that's definitely a lot harder on your PC. Like anytime you're dealing with like flow simulation, CFD analysis, that's always what kills you. We've been trying to do some aerodynamic simulations recently, and we basically just run into the problem where, like, yeah, 32 gigs of RAM and our top of the line processor is just not fast enough. So, still no information on what happened on this automated hold. We've been here for about 10 or 15 minutes or so. They do still have an option to recycle. Their quote was they're exploring options for recycle. So I think that's what they're doing now. Yeah, maybe they're... You know what? They actually could be writing software for the rocket right now. You never know. Because they might have like one little glitch and they just need to like, delete some lines of code and then it'll work. Who knows? Who knows what's going on in the back room there? Yeah, maybe it's compiling. It does seem like the rocket's still fueled, though, so I don't think they've given up yet. The thing is, though, I feel like they should be relatively less danger averse than maybe other rockets, because they can literally just 3D print a new one. It would probably take them not that long. And I'm sure they have a couple of rockets lined up right behind this one. But yeah, obviously you don't want your first rocket launch to be a failure. It would be a PR thing. It looks like we have a reset of the clock to 46 minutes, so this could be a recycle. That puts them right to the end, almost to the end of the launch window though, so this would definitely be their last chance to do this. Yeah, if it blows up, it would still be expensive. I wouldn't know if it would be so expensive though, because I mean, the whole point of this is that they want to prove out designing a rocket and building it super rapidly, and so they can rapidly iterate. Like, that's the whole selling point of 3D printing, right? So I think if this thing were to blow up, the perfect way to prove that would be
that we are going to recycle, and we have an updated T0 time of 15:55 Eastern. So again, that's 15:55 Eastern, approximately 45 minutes from now. We're gonna keep going.
All right, so it's officially confirmed. They're going to try to recycle 45 minutes. Yeah, what do we say the odds are that they're going to launch this time? I put it at 30% launch, 70% they will have a problem. Yeah, I hope they're not running Windows 10 on that thing.
Because of the previous automated abort, the stage 2 oxygen temperatures were out of limits, so that's why we had that abort at T minus 70 seconds. Now we're going to resolve this issue and continue on with our recycled and new T0 time of 15:55 Eastern.
So new theory. I think that the temperature of the oxygen tank got too high because the venting was insufficient. And of course, if the temperature gets too high, that means that the pressure is going up and chances of explosion going up. So that's probably why they decided the automatic thing would have called a hold. Yeah. So the question is that a sensor problem? Is that a software problem? Or is that actually a physical problem with the oxygen tank actually having a temperature issue? Based on this, it sounds like it was probably just a software thing. Yeah. Or maybe it got self-conscious because it wasn't pointy enough. Well, looks like we have another 40 minutes to wait here. Once they, the thing is that once they get these teething issues finished, the launch will get probably far more regular. Like if you think back to the SpaceX days when they were just starting up, like sometimes it would take them like weeks to get their launch going. Like they were calling holds all over the place. But now if you look at them today, like, you know, if they put a launch date on there, like it's pretty certain they're going to launch. You can relatively rely on it. Unless it's Starship, then you can't rely on anything. Did you actually see a guy climbing the ladder with a file in his hand? I'm pretty sure you're not allowed to approach the launch vehicle while it's fueled. That's a pretty high safety requirement. Basically, when the vehicle's pressurized, like you just assume it's going to explode. Like that's like the first rule of rocketry, of course. So they would have to depressurize if they're going to send a guy out there. Yeah, to be honest, Relativity Space has spun up pretty quickly when it comes to being able to launch a rocket. Like they started like, I don't know, like 5 or 6 years ago. So for them to go from that to launching this quickly, for this scale of a rocket, this is a medium class launch vehicle. It's not a small sat launcher. Like this is a fairly large rocket, 35 meters tall, like over 2 meters wide. It's pretty substantial. So it's pretty impressive how far they've gotten just with what they have. It definitely goes to show you that, again, it's show classing the strength of 3D printing materials, which is that you can quickly prototype. And they have a ton of like if you look at how much experience they have with their rocket engines, like they have tested the hell out of those engines. Again, one of the key strengths there being that they can just 3D print them, so they could quickly iterate between different versions of their engine. So for those who are just joining now, just to reiterate, we are currently just over 40 minutes away from the new T0. We've been in a launch window here for the last 2 hours, and it's a 3-hour launch window, so we have 1 more hour in the launch window where Relativity could launch the Terran 1. So this is most likely going to be their last chance. They have done, I think, 3 holds now, so this is now their fourth attempt at trying to get this thing going. Last time we made it to T-minus 70 seconds, and that was the point where basically the automated system called a hold. And the reason for that seems to be that the temperature of the oxygen tank was out of range. And as I said before, that could indicate a number of issues. It's not necessarily just a physical issue. It could also be things like software and sensors.
Quick update here. here that our updated launch time that's been confirmed with the range is at 15:45 Eastern. That is 3:45 p.m. Eastern. The T clock at the top of your screen is accurate and will keep you up to date as to when we are going to lift off.
Yeah, the wind looks pretty strong down there. But again, the wind on the surface is not so important. It's more the wind at high altitude that is more critical. And they also seem to care a lot about cloud cover because they actually want to be able to see the vehicle on the way up. Again, this is a test launch, so they want to be able to get some good data on the launch itself. But I'm hoping that Florida's weather will hold. According to our local Florida residents, it seems like that's sometimes a bit of a cantankerous issue, the weather down there. But yeah, if you guys are down there in Florida right now, in about 30 minutes, definitely head outside because you might be able to catch some fire and glory as this thing has maybe a reasonable chance of taking off today. They might be a little bit more bold on their last try to get this thing flying. So yeah, it seems like one of the issues they had with the hold before that they kept mentioning over and over again was that they were doing propellant conditioning. And it's a little bit unclear exactly what that means. But I think what it means is that it's just about like priming the feeding system and making sure that your feed and bleed is like working properly. You have to think about it, right? Because they're keeping the rocket on the pad, and they have a certain bleed rate that's there because the oxidizer is heating up and heating up and heating up, which means that some of it's vaporizing. So there's a rate at which you're losing oxygen, but you have to be filling the tank at the same rate that you're losing it. Otherwise, like, the tank levels are going to be changing. So maybe they're just having trouble with that. That could have been part of it as well. Yeah, so the frequency that we use, oh man, now I'm going to get this wrong. But I think it's like 432 megahertz, or it could be 868. It's either like 434 or 868. One of those is a free frequency for amateurs in Europe. So that's the one that we're using for that. But don't quote me on that. Again, avionics is not my strong suit, so I could be getting that wrong. Yeah, on those frequencies you can actually transmit quite a decent amount of data, so it's not like it's terrible. Do we use LoRa? This I don't know. Yeah, exactly. That's exactly. So the new time of 6:01 p.m. is for the propellant conditioning. But I think that comes from a while ago. Because I think they have a new T-0 now. Yeah, I wasn't really following their Twitter channel. Let's see what they have to say. Let's see here. Yeah, their Twitter feed is still a bit back from current. So their live stream is more current than the Twitter. Their Twitter still has them 2 minutes out from go no go. So yeah. The key to picking radio frequencies for like amateur purposes is just to find the one that you're allowed to use in your area. Like you shouldn't overcomplicate that too much, I don't think. And yeah. Usually the things you'll find on the market are those things that use those frequencies anyway. I find it kind of weird that Elon bought Twitter, to be honest. I think that was a weird decision. I feel like he should focus on rockets. We need more attention on that than on the other things in the world. It's a hard problem, and we need as many people as possible to be working on it. So if you're a young engineer out there and you're looking for a cool thing to put your energy behind, I think that's this is definitely one of the greatest challenges that humanity will face in the next 100 years, is trying to figure out how to make humanity a spacefaring civilization. So yeah, if if ASTRA decides to try to do something on Mars, maybe in the future. I don't think that's something we could pull off in the next 10 years, but maybe as the cost of space goes down, and this is what I hope for the future essentially, is that as the cost of space goes down, it'll offer more opportunities for like civilians to be able to do cool stuff in space. And maybe, you know, if the infrastructure starts developing to be able to actually commercially send things to Mars, even student groups can get involved and start, you know, trying to do stuff across the solar system. And it can be not just the domain of like, you know, rich people and governments, but also a domain for civilians as well. That's kind of like, you know, the overall, I think an overall good mission statement for people that want to work in space, is trying to bring space down to regular people. Because I think it's a domain where we should all be working in, not necessarily working in, but like be able to participate in. It shouldn't be like locked out. Yeah, I don't own a spacesuit, so I'm not sure I could. I wouldn't recommend sitting in one anyway, unless you're in space. They're very uncomfortable. They're kind of designed more for space. This is actually another avenue that probably needs a little more work in the future, is trying to figure out how to make a spacesuit that is actually ergonomically like possible to like do things in when you go to other planets. Because like the big bulky chutes that they have now are just clearly not good. There was just a helicopter that went by or something. I thought they cleared the airspace. What the heck? Yeah, spacesuits definitely need some improvement. There's been a couple of companies that have been like experimenting with doing like what do you call it, like spandexy type suits that kind of like compress your body fluids and kind of make it feel like there's a 1 atmosphere of pressure, but that is not something that's been proven yet. But I think there's some promise in that, and I think it'd be really cool to have like a spacesuit that's like all spandexy. You definitely would be way more mobile than you are in the big bulky ones today. Yeah, the helicopter is bringing in some new people to fix the problem. Maybe they're flying in the experts. You'd think they'd be able to just kind of like, you know, zoom them in or something. I don't know. It's probably some military thing. But yeah, there's definitely room for people coming in with ideas in terms of developments in space that could come from all places in the building and engineering world. It's not just like rockets and stuff. Like little things, simple things like designing a spacesuit. Like that's not a rocketry thing. That's not a space thing necessarily. It's like a textile thing. Figuring out that challenge is just as important as all the other ones. Yeah, maybe they're asking the Space Force for help. I don't think Space Force would help them. You know, they're very secretive. They should go over and ask SpaceX. They're not too far away. They have some experience with Methalox engines, after all. Probably have a lot of experience with oxidizer tank temperature issues as well. SpaceX actually does a really weird thing where they supercool their liquid oxygen. So they don't just cool it down to like the, I think it's like minus, it's just over minus 200 degrees Celsius that they have to cool it down to get it to be liquefied. But SpaceX actually takes it down like 20 degrees even colder. So it's almost freezing. And they do that so they can like get as much liquid oxygen into the tank as they possibly can. So that's what you do when you're like super experienced with liquid oxygen. I don't think relativity is quite there yet. I would also be curious how they pressurize their tanks. There's a couple ways you could do it, but I don't think they've released any information about how they do that. I wonder how much liquid oxygen they've actually burned through, and methane they've burned through, just letting this rocket sit on the stand. Like, they're constantly venting it, so, like, my goodness. It's probably costing them just, like, you know, tens of thousands of dollars per hour that they let this thing sit on the pad. For an amateur rocketeer, that's like, oh my god. Money down the drain. Do you mean like priority payloads for going to Mars? Because the answer would differ depending on what you mean by priority payloads. Like, is it for Terran 1 or for going to Mars, or what do you mean by priority payloads? To Mars. So, yeah. I would think that the priority would be to send the like infrastructure that you need in order to support humans. So, definitely a fueling base where you can like fuel ships and stuff. That would be a high value payload. Anything that can build structures would be a high value payload. Anything that could help build like you know, greenhouses or plants or things like this, that would be a high value payload. Basically all the infrastructure you need to support life. Then you can just send humans and then everything's kind of set up for them. The other way you could go is you could just say, well, we're sending this huge starship anyway. We may as well, we could just say, okay, Starship is the base. And you could just send people, like 10 people on Starship with like a bunch of food and just have a mission that's just Starship. And the people live off of Starship for a year while they're on Mars. That one's a little bit less ambitious, I would say, and maybe more realistic. But I don't know, if Starship gets spun up really quick and they're launching lots of those, it might make more sense to actually establish more of a presence. And I think that's kind of what Elon's mission actually is, which is to try to establish more of a permanent presence rather than just, temporarily going there, put boots on the ground, and then come back. I think that's not really the spirit of his mission overall. Yeah, abandoned rocket research facilities. Kind of sounds like a missile research facility. You sure it was a rocket research facility? If it was like silos and stuff, that's sounding a little bit more military. Yeah, so for those that just got back, we got delayed again, of course, but we are now coming closer to the T-0 time. We're down to 24 minutes. If it gets delayed again, it will be an abort.
Minus 23 minutes and 56 seconds. We're currently waiting for an update from Mission Control. Let's continue listening in and stand by.
They're probably going to go through the go no go poll again when they get to T-minus 15 minutes, I would suspect. So that would be the next thing to look out for. If they do have a hold at this point, I don't think they'll have enough time to recycle because their window expires in 40 minutes. And yeah, usually when they're doing the recycles, they're recycling back to basically 50 minutes. And they definitely wouldn't have enough time to do that at this point. I don't think they have the operational capability to recycle back to T-minus 15 minutes like some rockets do. So I think that would be the end for today. But don't get disheartened if that happens. This is just part of the process for developing a new launch vehicle.
DLD. All parties, we are scrubbing operations for the day. Thanks for playing.
Yeah. Okay, so it looks like it's a scrub. Well, at least they got the opportunity to fill the rocket.
All right, you just heard that update from Mission Control. We are unfortunately scrubbing today's operations. We're going to stand by for additional details from Clay Walker.
Yeah, this is too bad. But, that's kind of part of the process. It's better that they, figure out all the loopholes and the stuff that's going on while they're doing this process. So rather than they have an explosion on the pad, that's never good. Yeah, for those of you who don't know, today is International Women's Day, which is why we have, why Relativity is trying to showcase the females that they have working for them. Space is, of course, not just for the guys. The girls have just as much right to be there as well. So it's important to encourage and to showcase that women can be engineers too, and women can be in space just as much as men can. Yeah, sometimes having a rocket failure can be a success because it can reveal failures that you wouldn't have seen otherwise. If the rocket would blow up, I don't think that it would be that high of a cost for them because, again, they're 3D printing these things. They've already built all the tools and whatever they need to build the rockets, so building another one would be like a trivial cost. They literally have raised over $1 billion and they can build these rockets for on the order of tens of millions of dollars. So if it did blow up, I don't think it would really hurt them financially. I think it's more of a PR thing. I don't think they want to have an explosion because it would cause people to lose confidence in their technology. The main thing is they want to proof the 3D printing technology and show a case that the structures are strong and able to withstand things like rocket launches. So if the thing blows up, then they're not really able to show that in such a strong way. So maybe, yeah, that might cause them to be a bit more skittish than they otherwise would be. But yeah, there's no need to worry about it. They're going to be back on the pad pretty quickly, probably even within a week, depending on what the issue specifically was and whether they can fix it. So I'm sure we're going to see this launch relatively soon, if not today. Yeah, rockets blow up all the time today. The goal would be to make sure that in the future, rocket launches are like, airplane flights. They're that reliable. That's important on the step of getting to the place where, humans start traveling into the solar system a bit more, because people like you and I are probably not going to want to get on a rocket that is potentially going to blow up all the time. You want to be having a bit more safer of a system than that. And planes were a lot like that back in the early 1900s. They were very unreliable. Like, you were taking your life into your hands every time you took to the skies. So hopefully rocketry develops in the way where it gets to the point where it's a little bit more reliable. Maybe ChatGPT was responsible for some of the source code, and they discovered some errors because of that. Who knows? I bet you in the future that AI will be writing a lot more software, so it could be something to watch out for. Yeah, you're welcome for the science and the rocketry and space talk. Always happy to spread some information and keep people excited. And I hope that you continue to stay excited about space, because this is truly the future. Anyways, at this point, I think it's quite clear that we're scrubbing. They're going to give us some information potentially, but to be honest, I doubt that information will be too interesting. I hope you guys come back for the next launch attempt. I don't know exactly when that's going to be, but stay tuned on social media for when they say it might, when the launch will start. Yeah, in terms of starting things like Discourse server, that's probably a good idea. We're a relatively new group, so a lot of these things have not been set up just yet, but that's definitely something that is going to be potentially there in the future. It seems like there's lots of people that are excited about the project and want to discuss and talk about it.
Unfortunately, we just got word from the launch teams. We're scrubbing for today's launch attempt due to A, remove that and put in her for.
Man, that was some short information there. Didn't even give us that much time. But yeah, it's definitely going to get delayed to a different day now. So, yeah, thanks guys for hanging out and talking about rockets for the last little while. We hope that you join us in the next one, and I hope that you keep staying excited about space and thinking to the future. Remember to expand your horizons.